Think we're all set. Slim, thank you, thank you. Welcome in, people. Just getting things set up here. Hey, Fembucks. Oh, you're welcome to join if you'd like. We're going to be talking about philosophy and math. I got an electronic copy on the screen. I also got my physical copy here. Just waiting for Slim to hop in, and I'm kind of making sure things are actually working. The YouTube stream is going? It is. Okay. Good. I feel like I'm forgetting to do something, but I think it's all good. See, Slim just hopped into the Discord. Let me give him permission to join. Okay, Slim should be able to hop into the voice chat. Hello,
Hey,
hello.
Dom.
How's it going?
It's going well. I think I need to mute the stream. Okay.
Oh, yeah, that'll be helpful.
Yeah, that's much better. Okay, great. Fantastic. How is your day going? How are you enjoying your vacations?
It's really nice. All I've done today is laundry, but you know, that's still good.
Yeah, having clean clothes is like one of the biggest achievements of my life.
Yeah. Same.
Yeah, yeah. So do you know if anyone else will join?
So Zach said that he was interested. I think he's still live right now, though. So if he does join, he'll be late.
I guess we can, well, I'm not sure how long we can wait, or if anyone else is interested. Maybe if you announce it right now, someone else would be interested. What about you, Fembooks? Do you want to talk some math philosophy?
Yeah. If we don't get anyone like a minute, we can just kind of start. I think.
Yeah, I don't. I mean, I don't mind starting either. I just don't want to exclude people if they really want to do it.
That's fair. Yeah.
All right.
Up to you, $10. That's okay. Hey, Jed. Yeah. But just the normal voice chat as always. Oh, Zach is messaging me right now. Oh, Zach is gonna stream it. It sounds like, which is
Cool,
completely
cool.
fine. While he builds Legos. Let me get Zach in the title too then. I hate it when it doesn't autofill. Hopefully that works. Hey, Flofi. Math philosophy is scary. It is a little scary, but hopefully we'll make it make more sense. It's okay if you haven't done any reading 10 bucks. I think the things that we'll be talking about, anyone can kind of have an opinion on. Well, at least anyone who likes math. I might quickly pop up in Zach's stream just to snoop on what he's doing.
All right. Yeah, for some reason my server didn't get the notification of your stream, so I
Oh,
don't know
sometimes they're a
why.
little delayed, or my bot to publish things maybe isn't working.
No, it is working. I'm just gonna copy it.
Oh, interesting.
I don't know why. I changed the layout of my server and now some things are not working quite.
Oh, I saw you did change it up. Yeah, hard locked first again. Yeah, I see Zach is breaking out his Legos. Don't know if when he plans on joining. Okay, he's showing a crossword or something to his stream. I think we can just start talking and then he'll join
All
when he
right. Yeah.
joins.
Yeah, I guess that works. All right.
Shouldn't be long.
So we are reading Thinking About Mathematics by Stuart Shapiro, and you have some pretty. I mean, I made some notes. I don't know if you want to share them or if we can just riff-raff a little. Um, I mean, what would you like to do?
Uh, you could fit Femlux and Hey Clonk. I guess I guess it makes sense to me. Like I grabbed an electronic copy of the book and just maybe like going through it in order the book presents it, and as we
Yeah,
find things do we want to comment on, we can talk about it.
yeah, that sounds great.
Okay.
That sounds great.
I might just scroll past the preface here, unless you had anything on that part. But
No, the thing is that the preface is very, I mean, because it wants to give a whole picture of the book. So I think we can just skip it.
okay. Oh, I guess first, how far did you end up getting in the book?
I think I got up to section 4.2, so
Ooh,
Kant.
okay.
I got up to Kant.
You made
Where
him.
do you get?
I got to the end of chapter 2.
Okay. So you,
Ooh,
excuse me.
don't die on us.
Let me need some water.
Oh, yeah. Take a minute if you need it.
Yeah, give me a second. I'll be right back.
No worries. Okay. Yeah, Zach messaged me saying he would build Legos and discuss. I'm not sure when he plans to discuss, but he's always welcome to just join. I'm pretty sure he has permission to just hop in, so. And I told him that he could. I'll send him another message. I'll send him
Hey, Don. Hey, Slim.
Hey, Fembucks. How are you doing?
Doing all right. I couldn't pass the chance to say hello.
Hell yeah. Sorry, I'm just writing Zach a quick message and I'll be able to speak better.
Yeah, take your time. Yeah, I should have looked at this book. I looked at it a little bit and I don't know, I just didn't read it. Didn't get around to reading it.
Yeah, no worries. It's kind of a lot to read. Oh, here he is.
All right.
Here I am.
We got the crew here.
All right, hello, and let's just
Hey,
do a quick
hey,
sound
Zach.
test. I am syndicating this discussion with y'all on my channel. So, who's here?
We got me, Don,
Box here.
Fembox, yep,
Benvox? Yeah. You, Don, and anybody else?
and Slim.
Yeah, I just got back.
You just got back. Okay, Slim. We are syndicating this on my channel. I'm doing Legos as we do this, so I'm
Cool.
gonna enjoy doing that at the same time. I like to chat with people as I do stuff, which is anyway, it'd be fun. So I'll shut up and basically let you all talk, and I'll chime in.
Okay.
I'm the latecomer.
No worries. So So the way we're planning to do this is that this discussion is based off the book Thinking About Mathematics by Stuart Shapiro. And so on my stream, I'm showing the actual book, but we're just kind of going to scroll through it. And as we see something we want to comment on, we'll kind of explain what that is and then like talk about it.
Yeah.
So
So even here in the table of contents, well, one thing you can even start with the title of the book, like thinking about mathematics. Mathematics seems to be something that we do, but not something that many people think about. So you think doing math, but not think about math often. So yeah, like just the title is something to consider. But the in the first part, which is basically what we read on perspective, the first chapter is gonna give you an idea of why philosophy might get involved in math and in which ways. So that's the first part, and the second chapter is just some random questions. Well, not random, but some of the important questions that philosophy try to address with math, right?
right.
Yeah. So I'm not sure if you have any other thoughts on the title of like I mean, you do math streams for a while, and now you're doing your. Did you ever think about these issues, or have you ever thought about these issues of mathematics, or
Uh,
have you thought about mathematics? I guess that's the question.
this book has made me realize that I sort of have in like some specific like applications. I wonder like what is this thing really? Or I've had the thought like often the first chapter of a textbook will be their kind of like philosophy-ish section before they actually get into it. But
Yes.
I've never like specifically have thought about math in the way the book is asking us to.
Yeah, and I think it might be a similar experience for people that sometimes they may ponder on things that don't seem math, but they may ponder on them, and it's not treated in any course, basically. So maybe just people dismiss those questions and ponderings.
Right. And so that's something that actually pulled in. I pulled two examples of kind of something like that from a physics book that Femlux and I went through on electricity and magnetism. And actually, I guess it's as good a time as any to bring it up.
All right.
Oh,
So-
I see. Section 1 is called Attraction of Opposites.
Oh yeah, that is fitting for E&M.
Or magnetism, electromagnetism, right?
So
What about you, Fembooks?
yeah.
Well, Don finds that book. Do you think about math, or do you just do math?
I mainly just do it, but I guess, I mean, in the practice of doing it, I think you have to think about it a lot. And the more math you do, I think the more you just naturally think about it, a bigger picture of it or something, and realize you know almost nothing. It's a sort of a philosophical standpoint. I know almost nothing. I don't know.
Indeed. Yeah, like so you wanna bring up that example, or should we just go to? Okay, cool.
Oh, yeah.
From the book.
So this is just from chapter 1, and they're talking about electric fields here, but for the sake of keeping it like mathy, we could just call this any generic vector field, and it'll be the same. So I'm talking about the section I'm highlighting here, and then the next few sentences on the next page. So the book introduces the idea of an electric field, and they say the reader might want to ask, what is an electric field actually? Like, is it a real thing, or is it just the name for something in an equation that you do? And the kind of humorous response that the book gives is, first, since it works, it doesn't make any difference.
But that's also a philosophy that you can take, right?
Yeah.
Well,
That's
the
all.
same, if I may, the thing that comes to mind is the discussion about vectors, actually, because like a computer scientist would see a vector as something you store in memory, whereas a vector for a physicist or a mathematician is just this abstract structure that we can use. Or is it an arrow, or is it a what? Like what is a vector philosophically? And the representation of that is usually based on what you're studying it with respect to. sort of like the electric field thing.
Yeah, so it's just like kind of funny because like the field isn't necessarily physical, but like it still like does what you want it to, and it's helpful still for like intuition. And so the author kind of gets into it later, but that's, I think, an example of kind of like philosophy of this stuff comes last, and we just kind of care about the actual physics first, for better or for worse. The other, or sorry, in the physics book, there's a second answer to this question, which I'm not sure really answers it, but he was on to say the fact the electric field vector at a point in space is all we need to know to predict the force that will act on any charge at that point is by no means trivial. So just that it's a really like helpful thing that is kind of indispensable in physics. Sorry, there's another playing. One second.
Okay.
Thank you, FA. I appreciate you. Go on, Slim.
And I think that it starts to point out to one of the questions that we will talk about later, which is, okay, if you are interested in the physical world, and let's say your goal is to predict anything like how fast an object falls, why is math so effective at doing that? Right? Is one of the questions that eventually, like I think in chapter 2, is going to be part of it. Like actually, chapter 2, 2, 3, right? The mathematical and the physical is one of the main questions. But yeah, okay. So do you want to start then with attraction of opposites?
Sure. So yeah. Oh yeah. Go on.
I have a few notes, and I'm just going to read quickly. The whole idea here is to tell you what is so interesting about mathematics for a philosopher, or why philosophers might be interested in mathematics. And then they start telling you how mathematics is the prime example of rationalism. So philosophy is one of the things that philosophy cares about is how we build knowledge, right? Philosophy is interested in that. And one of the doctrines is rationalism as opposite to empiricism. And then empiricism tells you that our knowledge comes from experience. But mathematics presents like a challenge to empiricism, because a lot of the mathematical truths that we develop, that we find, are not necessarily based on experience. You may need experience to kind of like get the first setup, but after that you start deducing things that you don't really need to do any experiment in the world to check if they are true or not. So mathematics presents a challenge to empiricism, and is kind of like the biggest achievement of rationalism. I think they talk about that there.
I can't highlight text in this, but and at the start of this second paragraph, they get into rationalism.
Yes, and then he also goes and discusses of how like there was no distinction in the past between mathematicians and philosophers. Basically, like up to some point, we still have this idea of the Renaissance man or the Renaissance person that would know everything, a little bit about everything, and then philosophy and math weren't like distinct subjects, and people would do both of them. But as we have specialized more in knowledge, then it's much harder. Like even between mathematics, you may not know what someone in a different area is doing. You might not be able to understand it, or it might take you a long effort to understand it. So I guess part of the question is, or what he's trying to tell us is that it is still, even though we are in different areas, philosophy and mathematics, it might be still interesting to have some discussions between the two of them. What do you think about that?
Yeah, it's like this kind of realism and anti-realism thing. I feel like this is leading into.
Oh yeah, yeah,
And I believe like I think it's pointing to, like, it starts off with talking about Plato, and I think he's an example of a like very, I think he's very realist from what I remember.
yeah. Yeah, yeah. By the way, do you want to tell our friends what is realism and anti-realism? I mean, that's later. That's in chapter, yeah, it's somewhere else, you know. But yeah, it might be worth to introduce them now.
Yeah, so the idea of realism in math, if I'm going to get it right, is that it's the idea that the things we talk about in math, like mathematical objects, are real and they exist somewhere in reality, independent of the mathematician's mind. And an anti-realist would say that mathematical objects are just a mental construction and don't exist in reality.
And well, it depends on the branch of anti-realism. Like
That's true.
nominalists may even deny the existence of mathematical objects at all, like even in the mind, right?
Right.
Yeah. So yeah, like and this he's gonna get more into that again in future chapters. But basically, there are two things that he is concerned as important problems in mathematical philosophy. One is the ontology, and ontology refers to the existence of objects. And the second one is epistemology, which is about knowledge, like how we form knowledge. And then he says that we can have, or he makes the distinction between realism in ontology, which basically tells you, like, if you're a realist in ontology, you would believe that the number three exists somewhere, right? And if you're an anti-realist in ontology, you would think that that the number doesn't exist, roughly speaking. But if you are a realist in epistemology, it means that you believe that truth facts actually exist. Like truth is something that actually exists. But if you're an anti-realism, you may believe that truth is just, it could be either it doesn't exist, or it could be just a social construct, for example, right? So yeah, a lot of distinctions there.
Yeah, there's a lot of is and isms and things to keep track of with their own branches.
Yeah, yeah, there are a lot of them. But yeah, like again, in the first chapter, in the attraction of opposites, he's just making the case of why, despite the fact that we are despite the fact that philosophers and mathematicians don't speak that much, there still could be some interest for mathematicians to study philosophy and for philosophers to study math. And he gives three reasons for the connections between mathematics and philosophy. The first one is that mathematics and philosophy are both the first intellectual attempts to understand the world. He says that they were generated in ancient Greece, or at least the version that we get of mathematics and philosophy is very influenced by ancient Greece. That's the first one. The second one is that if you are a philosopher, mathematics is like a clean problem to study, because all the problems in epistemology, ontology, semantics, and logic are very clear, have very clear statements in mathematics, right? Like, for example, the problem of realism is not only a problem in mathematics. A philosopher could be interested in wondering if the world actually exists, or I don't know. Some philosophers may think that it's a simulation, for example, right? And but then, like, if you think about that problem, like in the real world, is much harder than the problem of in the particular case of mathematics. And the same for epistemology. Like, does mathematical, again, recall that epistemology is about knowledge. So does mathematical knowledge actually is a valid type of knowledge or not? That problem is a little easier than thinking of general facts, right? So that's the second reason. And the third one is for epistemology. Like, it seems that many philosophers are interested in how knowledge is created, And then because of that, since mathematics seems like a very efficient way of creating knowledge, they have to kind of like they have to study how that problem relates to mathematics. Does
Right.
that make sense?
Yeah, and so I do like that before the author or before he even like went into all this, he did like make the point that like we've become so specialized today that it's become much more difficult for us to do this, but it's still important. But like he says, like algebraists cannot follow developments in analysis. Philosophy of physics is incomprehensible to most ethicists, and so it's become more difficult, but it's still important for the reasons that he says here. And I believe there was a chat message that was relevant that I wanted to bring up here. Dang it, now I can't find it. Oh well. I lost my thought there. But yeah, I really like the connection between scientific effort and mathematics. The other thing I wanted to bring up from the E&M textbook was on page 11, because actually the discussion that Zach was having this morning with Penn Center on exponents and logs made me think of this. So in the section of the book, they introduced Coulomb's law, which is just for how two charges attract or repel each other. It looks just like the equation for gravity, but with charges. It says, to summarize, we have every reason for confidence in Coulomb's law over the stupendous range of 24 decades in distance, from 10 to the minus 16 to 10 to the 8 meters, if not farther. And we take it as the foundation of our description of electromagnetism. And I was kind of thinking of how we use this kind of like scientific notation with 10 to the minus 16 and 10 to the 8 to describe kind of the success of this law of physics. The fact that it can work over such a range of distances in many different orders of magnitude. And I thought that was like a really like nice example of why math is helpful in science. And I think that's reminded me of what the comment was, but now science. Oh yeah, okay. I'm not sure how you pronounce it, but Bajezs earlier said we can describe physics without numbers. Science Without Numbers by Field is a good book for argue with Quinn Putnam argument. So I didn't realize that was a possible position to have, science without numbers, but that's cool to hear.
Who said that?
I'm gonna guess it's like Bayesh or something, but Bajezs.
Okay,
I'll copy paste it. It was a little bit earlier.
But yeah, like yeah, there are definitely philosophers. Also, there are people who have taken the point of view that mathematics. So I guess okay, let me trace back a little. So the example that you are giving in the physics books is kind of like what you are arguing is that mathematics gives you a nice language to make arguments. Like in this case, you have the argument that this theory is successful because it works in this range of numbers, which is very easy to describe with math. And this is something that we kind of take for granted, that mathematics is like the language, and you hear this a lot, that mathematics is the language of nature. This is something that you hear a lot, but there are philosophers that have argued against. I wonder if that's what the comment was about. They said that basically you don't need math necessarily to describe the world. We just have settled on using it. But it's a point that is, I mean, I guess you could make an argument based on that point, but I think it's a hard argument, right? To say that math is not necessary to describe the world.
Yeah, it'll be a really weird kind of science you would have if it lacks any sort of math, but you can still have like theory and observation, I guess. Just maybe it wouldn't be very exact.
Yeah, like
if I may ask, when we're using the word math here, I'm gonna just being a little nitpicky here. are we talking only about numbers, or the relationships between things, or like what are we defining as math? Math is arithmetic. What I guess let's be a little more clear. Because when you say a math without numbers, like I don't know if you can do it without relationships between things, between quantities and such. But without numbers, I know that a lot of physics problems, you're encouraged to do things without numbers, find relationships first, and then insert numbers as appropriate. That's a common strategy you'll hear given to students.
Yeah, I
Yeah,
guess
so
those are still proxies for numbers, though. I wasn't thinking that that is different.
Okay, so it's like we're taking number here to mean measurable quantities, then, because like that's
I guess, yeah.
okay. I just want to make sure that's clear, because when I'm hearing the word math described, I'm down with that. I just as the cool kids say.
hmm
Um,
Okay. Slim, were you about to say something?
no, yeah, basically, yeah, that's also a hard problem. What is exactly math, right? Like, I mean, it's not obvious. We just, I mean, there are areas that are very well established, and if you are doing arithmetic, then you say, okay, this is obviously math, or if you are doing calculus, this is obviously math. But yeah, what is really math? And I don't think we have got in any part of the book to have that discussion quite yet. But it's also a discussion to have, right? Like, is math just an extension of logic, or what makes math math? In the past, I think the easy answer is it was basically math was geometry. Basically, everything that you could do with geometry was math, and that was it basically. But yeah, like now the answer is not as clear. There are so many things that are not necessarily geometrical that we count as math. So yeah, I don't know. It's a very hard question to put a limit on what math is. But I think that, yeah, like for the purposes of the discussion, we can think of what Don was saying, like studies of quantities and magnitudes.
Okay. Um,
Yeah. By the way, there is also, talking about realism and anti-realism, there is an interesting discussion there at the beginning on how, for example, for Plato, I think that's in the very beginning, no, like, so Plato was a realist. So Plato believed that, again, and in that time geometry was math. So Plato believed that the plane, the Euclidean plane, existed, that the lines existed, somewhere. And
mhm.
then Plato had this argument saying that mathematicians didn't know what they were talking about, because they would say something like, construct a line, but what is it to construct if the line already exists, right?
Yeah.
And then he has a whole argument on how they should be more careful. And but basically, what he what he ends up saying is, like, when people say construct a line, what they mean is choose the line that already exists that passes through these 2 points, right? But it's not that you are constructing the line; the line already exists. And how the opposite view comes, like, eventually with constructivism or intuitionism, in which actually you need to construct the line, and you need to do the constructions, and this gives a difference, right? Because if everything already exists, I mean, this is subtle, but it's actually important. If everything already exists, then if you take any math proposition, then it has to be true or false, right? Because everything already exists. So if you give me any math proposition, it has to be true or false. But if you have to construct things, then in order to make them true, first you have to construct them, right? And then it's kind of like believing that things are not true or false until you actually can show them, right? And that gives a different perspective on, again, on epistemology of what is how we define truth, basically. But yeah, so that's on the first chapter. I don't know if you have anything else from there.
Um, I gotta see. Yeah. So I also thought that point, that argument from Plato was really like interesting. That you don't construct things; they just exist. Um, is this where, okay, they go into intuitionism.
Yeah, intuitionism is, yeah, I think that's where, yeah, like in intuitionism, for example, yeah, like this part in logic that in that page that you are showing, um, uh, like the example is that we use constantly the law of excluded middle, right? In mathematics, we use that
Mhm.
if something is not false, it has to be true, right? But for a constructionist, that's kind of weird because the fact that something is not true just means that you haven't constructed it. And then it's not necessarily like the negation of, it's not necessarily true that something is true or false. You know, I mean, I know this is a very weird way of thinking. And the example, I'm butchering it, but the example that they give with the for all and there exist is precisely that. I don't know if you want to reread that part, like we can actually talk about it a little because it's pretty interesting.
Oh yeah,
Like the
here it
difference
is.
between classical logic and intuitionistic logic, it has a lot of philosophical roots. Yeah.
Right. And so it's kind of interesting. We're like, we use the law of excluded middle all the time as like a proof technique.
Yeah.
But I would say like if you're doing some type of like novel math, um, and you're just like, you know, developing that for the first time, it's probably, you probably don't really think in those terms. It's more like I'm trying to make this definition for some mathematical object, but I can't prove anything with it yet, or it's not useful enough yet. I feel like mathematicians kind of do a little bit of both depending on what they're doing. Where if they're not, I guess they're still always saying things are always either true or false. But I feel like when in the act of constructing math, we often, I feel like we kind of relax the excluded middle law a bit. Where I guess where we would point to it as a problem with the math that we're trying to build.
Yeah. Yeah. Yeah, definitely. Like sometimes, yeah, like the act of, yeah, I think what you are saying points to how the act of doing math is very different than the act of reading math. Like when you read the book, everything seems like it's already done, right? But in the process of constructing those things, yeah, you have to try things and see, okay, what is useful? What is actually describing what I want to describe? Is that what you are trying to say?
I think so, yeah. Although you could even take issue with the idea that you can construct math, I guess, if you're Plato. But
Well, the thing is that, like everything in philosophy, tends to have this flavor in which if you accept something that kind of like makes sense to you, if you keep pushing it, eventually you get to a problem that is also hard. And then the problem for Plato is like if mathematics exists, uh, for Plato it existed in a realm that was not physical. So numbers existed in a place without position or form or anything like that, right? But then the problem is if math lives there, then how the hell are we getting access to math, right? Like if there is a parallel dimension or something like that where all the math concepts are, how do we get to see to see math in our world, which is physical? And then he has to come up with explanations for that, right? And some of the explanations get pretty weird for that. Yeah, because yeah, like that is it clear? Maybe I'm not expressing myself too well. But do you see what I'm saying? Like for example, if you believe that the mathematical objects exist in a different realm that is beyond the physical, why do we have math in this world? Like how can we figure out that those mathematical concepts? Is
uh,
that like a valid question?
yeah, honestly, so like the book talks about that question a lot, and I'm not quite sure I understand what the big deal is, I guess.
You know, like the big deal is I think is the following. Like, let's think about a different question. Like, free will. Do you think that humans have free will?
Oh, that's another one I
That
don't see the big deal, to be honest.
well, but the thing is the following. If you believe that I mean, because this is kind of related. Like, if you believe that humans have free will, right? But then you have to make sense also with the fact that you believe that means that some way somehow humans have the ability to change the laws of physics, right? Because if you believe in the laws of physics, it means that every time that something happens, it's going to happen in the same way, that your neurons are going to fire in some way somehow to figure out how the actions that you want to to perform, right? And then if you feel so there has to be a mechanism such that you are able, so that your brain or your persona is able to bend that inevitable law of physics, right? And then, like, for that, again, like, if for many people, if you believe in free will, then you have to come up with, for example, the idea of the soul, of the human soul. But then that's like a concept that is not in the physical world. And then the human soul is the thing that has the capacity to change the physical world. But how, right? What is the mechanism? Now, this is an explanation. I mean, the analog that I want to make is that in mathematics now you have the same thing, right? Like, you have something similar. If the mathematical concepts lived in a different world, then how come that people came up with the concept of numbers? Like, if they were in a place that we don't have access to, how we're able to come up with these concepts? So the answer that Plato gives to that question is that it's actually our soul. Again, he uses again, like, and he explains it somewhere in the book that basically our soul has access to that other realm, and then because of that we get hints of that, right?
Right.
But then yeah, then basically you start needing some sort of mystic, they call it mystic, a mystic answer to the question, which is similar to the question of free will, that we need kind of like a mystic answer to to make sense of the free will in the way that we think about it, right? Like, you are able, that you are not controlled by the laws of physics when you make a decision. Well, obviously you are still restrained by the laws of physics, but if you want to drop a cup or to grab a pen, you can do it, right? You don't have it's not something that is being told to you, it's your will, right? And here is something similar. The fact that we are able to come up with those concepts, if those concepts exist somewhere else, then there has to be a mechanism, so we are able to do it. And then the answer that Plato gives is again that basically our soul had access to uh, to this realm of numbers, and then we were able to see those shadows and come up with the numbers ourselves.
So to echo a little bit of Platonism here, um, I mean the concept of the number four, for instance, exists inherent of my holding up four fingers, or pointing out four Legos or something like that. Like the concept of four exists independent of representation, right? And so as I'm listening to you talk about this, and as I'm reflecting, that's what I'm feeling like Plato is talking about here, is that four exists independent and we have access
Yes.
to that, right?
No, so yeah, so for Plato, the numbers existed independently, right? Like, and then after that, it came Aristotle, who said basically that the number four, like for Plato, the number four just lives somewhere, like heaven or whatever, math heaven or something. The concept is there, and the only thing that we get to see are kind of imperfect realizations of the number four. But for example, if every single group of four things disappeared from the universe some way, somehow, for Plato, the number four would still exist, right? Let's say in the universe something happens and every human gets evaporated, and every intelligent being gets evaporated, and everything that contains four elements that you could form four elements gets evaporated. For Plato, the number four would still exist, even if there are no minds to think about the number four, right? Um, yeah, so that's the realism that Plato is talking about. After that, Aristotle came and said that no, that the number 4 didn't exist in a different realm, that the number 4 was just in was basically all the things that were 4. Like all the groups of 4 were the number 4, and if those all for whatever reason all those groups disappeared, then the number 4 would stop existing, right? That's a different version of realism. No, the advantage of that one is that it doesn't need to invoke the mysticism that you need, like a way of accessing the number like from a different realm.
Yeah, but what if all the 4s vanished, but you had 2 sets of 2 and they came together?
Yeah. I mean, yeah. The concept with 4 might be not. Yeah, but you can imagine this because 4 is very small, right? But I mean, you can imagine that there is like a maximum number. Like if the world is finite, right? Then there is gonna be it might be a gigantic number, you know, and that's the maximum number of things that you could have. Maybe the number of atoms or quarks or whatever, and that's the largest number. And that plus 1 doesn't exist, right? Like according to Aristotle, at least.
There's no infinity here. He's removing infinity from the
Well,
discussion.
I mean,
Infinity enters the chat through Cantor, of course, but like, I'm just that's what I'm trying to reconcile here. Is like, what is he just saying that there's no unbounded thing?
yeah, I mean, again, this is just for the purpose of the philosophical argument, right?
No,
Like,
no, I'm saying that if I'm understanding Aristotle's point of view, that's what I'm trying to point out, right?
yeah, like I think
This is not
Aristotle
a
believed.
combative, yeah.
So they made a distinction. I think Aristotle made a distinction between infinity and the potential infinity, right? Like you could always have one more thing, right? And I think that's how they used to interpret infinity in that setting. But yeah, I mean, for the sake of the example, I just wanted to give a point of some mathematical concept that, for example, maybe instead of numbers, you could think of I don't know, heptagons or something like that. Like for Aristotle, the concept of an heptagon exists in all the heptagons that are around in the world. If for whatever reason every heptagon was scrambled from the world, then the heptagon wouldn't exist. But this is kind of like problematic because there are things that maybe there is none of them in the world, but we can imagine them, right? Maybe no one had ever, or maybe in the world there is no regular polygon with a goggle of sides, right? No one had there to construct it, but we still can imagine it. And then for Plato, that's fine because the goggle, this geometric object, even if there is no realization in the world, it lives in the world in that other realm, right? But for Aristotle, it means that it doesn't exist. The concept shouldn't exist, even though we can imagine it. Okay. So you see, I mean, it's pretty subtle. You know, it gets pretty. I don't know. I don't know. I know that for many people, when they hear these discussions, it's kind of like, what's the point, right? What's the point? And
it's a way. I was talking about this on my stream earlier today. I think people are trying to make sense of the world and making a model that works for them, because a lot of these just reduce to me to a lot of just models of looking at the world. And as the worldview evolves and as people gain more information, they adapt their model to that new information. I was reading something earlier, and I don't know if Energy, one of my viewers, had mentioned it, but there was a philosopher. Let's see, it was the Quine-Putnam indispensability argument, and that the Putnam of the Putnam exam, Putnam, that one. And it was interesting to hear this argument about some things, and I was like, I think this is really Quine and Putnam trying to make sense of the world, much like Aristotle is making sense of the world, right? Like these are reasonable things that they're trying to fit their worldview using the technical language of mathematics or philosophy to make sense.
Yeah, that's exactly it. Basically, we are trying to make a sense of the world, and the whole idea, or well, obviously there are other versions, but one of the ways that you can do it is similar to how we do math. You have certain beliefs, and then you try to chase the consequences of those beliefs. And then if at some point you get a contradiction, that means that one of your beliefs have to have to not be correct, right? So yeah, and then the thing is that
Or if I may add to that, it's possible that you just don't have enough information. There could be, it could be correct, but we just don't have proof for it yet.
well,
That's
that's no. What I'm saying, yeah, like I mean, obviously that's another issue. But the thing is that,
right, yeah.
I guess what I'm trying to say is that many problems in philosophy. I mean, philosophy, like the things that you could test in the world, they kind of are not part of the realm of philosophy anymore. They move to science, right? Like, uh, like if you believed that you got heat from fire because you got warm from fire because there was like a ghost whispering or something, you know. I mean, now we have science, and those questions don't need to be addressed by philosophy anymore, right? But philosophy is usually addressing questions for which we don't have kind of like irrefutable proof. That's another thing, right? But if you are trying to address those questions, then one thing that you could do is you hypothesize of things, which is what these people are doing. You come up with a version of the world that works for you. For Plato, that was the version of the world that worked for him, right? And then you start chasing your thoughts and see if something may go wrong with the way that you are thinking, right? And obviously, some people may argue, okay, but if you believe this, if you are Plato, someone may argue, if you believe this, then the argument of the other person would be, how do we get access to that realm, right? And that's an argument to have. So Plato has to give like an answer. The answer again for him was the thing with the soul. But if you say, okay, I deny this is not my version of the world, and instead I believe that the things only exist in the real world, and like Aristotle, that things exist in the real world, that the number three is just all the collections of three, then someone else would tell you, okay, but then that means, like if you follow that logic, that means that if all the instances of this disappear, that concept stop disappearing. And then you have to answer if you are going to accept that or not. I don't know if this makes sense, but I guess I'm doing my best, not being a philosopher, to explain what I'm trying to say, you know.
Well, and I think these are useful. Like it's useful to think about. I think we're just trying to express different perspectives. Like this is a way of being rational about expressing perspectives. That's what I think about. What you're trying to say.
Yeah, I mean, and to me, this is not, because I think that one of the problems often is that when people have this discussion, one of the issues is that we want to be right. And to me, it's not about being right. It's just kind of like pursuing the train of thoughts and see what consequences we get and what kind of interesting things we can say, right? But yeah, I guess at some point, like it's much more fun if you give up the idea of being right when you think about these problems, in my opinion. You know.
So yeah, I with stuff with numbers, it kind of the idea that like at least a natural number can't be real is, or the idea that a natural number cannot exist is very weird to me, because I, like Zach said it earlier, but I think to make the opposite point, like you could hold up 4 fingers and that's the number 4. It's right there. And so I think if we at least in my opinion, if we want to talk about like whether like numbers are real or not, it kind of helps to talk about what set of numbers, because I do think it's weird to say that there's a physical distance that is length root 2, because how could we ever know that? We can never measure that. But mathematically we say that all the time.
But when you're holding up 4 fingers, that's an abstract, or that's a sort of a representation, isn't it, of some abstract concept, the concept of a number.
I think, well, any other being with a mind could look at your 4 fingers and count those 4 fingers. That's kind of why I think it's like physical and in this realm, I guess.
Yeah. Again, the problem with that, again, obviously for every single thing that we are gonna come up here or in the chat, any single thing, I bet you that someone else had thought about it. You know, I don't know. Like someone else had thought about it, and not only that, for every single thing that we say here, someone else has also thought of a counter argument.
Yeah.
You know, like it's just, I mean, we are not that deep into this to be like pushing the boundary of philosophy or anything like that. Like every single thing that you are thinking or saying, uh, like someone had thought about it and someone had thought of a counter argument. And not only that, most likely the people who have there, I can even say more. I can say that smarter people than all our knowledge combined have thought about them, and smarter people than all our knowledge combined had come up with a counter argument. Right? The only reason why again, that's why I think is instead of trying to be right, it's much more fun to just go with it and see if you get some interesting ideas. I mean, I'm just talking because I see a lot of people discussing in the chat. So I think that I just would like to keep for people to keep that in mind.
Yeah, and so the book gives like a kind of different example of the same idea. I really like the example that it points out with we often take in math the definition of a least upper bound. The book calls it impredicative,
Yeah.
which is a new word for me, but fun to say.
That's actually a pretty good example. You should explain it.
So yeah, so the kind of cool thing that this points out is that something I had never questioned before is that when we usually define least upper bound in math, we just say it's actually, how do we even it's hard to even like put into words, but you know, with a function that is bounded, you can name infinitely many upper bounds, but usually we just want the least of those. And so we define this least upper bound in terms of this set of all the upper bounds. And the issue with that is that it's circular. You're defining the least upper bound in terms of upper bounds, but like, what is the upper bound in the first place?
It's problematic. Like, for example, when I tell you that the square root of 2 is the least upper bound of all the sets that are smaller than they're like for a square root of 2, you would say that the square root of 2 is the least upper bound of all the sets that are smaller than basically that are smaller than the square root of 2, right? But then isn't that what I want to define? Right? I think that's your point, right? Like, for example, like you first you would need to gather all the things that are smaller than a square root of 2 to be able to say that the square root of 2 is the least upper bound of that set, right? So you get kind of like this circularity.
Yeah, and this is called I forget what it's called. It's like the Archimedes axiom or something. I might be forgetting or getting the name wrong. But I feel like there's a common like axiom name for this.
Well, Archimedean, the Archimedean
Property.
theorem tells you that there are between any two, so you can basically tells you that you can find a natural number that is larger than any other number that you pick. Like if you gave me a
never
number,
mind.
I can
Yeah.
find a natural number that is larger.
I must be getting it mixed up then.
Yeah, but yeah, like that was the argument of constructivists, right? Like before you, because I mean, this is the argument. I think this is the argument that you are trying to make. But let me know if maybe my way of explaining helps, right? If you like to construct the real numbers, you, for example, the real number is square root of 2. The way of constructing it is through a Dedekind cut. So in a Dedekind cut, you basically say that the number square root of 2 is the collection of all the rational numbers that are smaller than the square root of 2, basically, right? I mean, I could make a definition without making reference to square root of 2. Basically, I could say all the rational numbers such that when I square them, they are smaller than 2, right? But then to get the least upper bound, first I need to get all the collection of those numbers. But for every number that I put in that collection, I can always find a number that is larger and is still in that collection. So it looks like I never actually finished building those things. So I can actually find the least upper bound. Did that help, or it only confused things more?
For me, it sort of, but I'm seeing that there's like there's 2 people in chat who said that this isn't circular, and I think the point of this is that like people on the other side of this argument say that if you're defining the type of definition, or the type of definition that we're talking about is that we're taking a particular member of a set of things, and the argument for why it's circular is that how do we know this set exists in the first place?
Exactly.
Yeah.
Yeah, I think you explained it much better to me. I was trying to be an example, but yeah, that's exactly it, right? Like, how do you know that this set, that you can finish the set, not only finish it, you have to actually be able to find the largest element in the set, right?
Yeah, and so Ultraproduct saying we prove it, but like it, what if you prove it in terms of some other set that we don't know exists?
Yeah.
Like,
And
where
the
do you
thing is
start?
that when you start thinking about it, again, it boils down to the concept of proof. And as I said, many of these things, I mean, I'm pretty dumb. So when I say these things, they sound dumb, right? But these are things that very smart people have thought about it. I'm just not able to express them in the way that they express it. When you actually read the people who came up with these ideas, this idea that Don is talking about, I think is by Hayton. You realize what was the issue and why that's kind of important, right? And then yeah, you realize that basically what he's questioning is what we mean by a proof. Like deep down, he's questioning that because yeah, sure, you can say that you quote unquote prove it, but then there is a lot of meaning attached when you say proof, right? And then yeah, but yeah, roughly speaking, the argument is just what Don says. Like, how do you know that this first set existed in the first place, right?
Yeah, and so I guess the last sentence of this paragraph that I have on screen, it maybe summarizes it. One cannot construct an object by using a collection that already contains it.
Yeah. Yeah. And again, we are just taking at the arguments, and as you see in the next paragraph, enter the opposition, right? Like after you see the argument, you get the next one, right? Fluffy saying that there are models where the set, in fact, does not exist, and you can meaningfully, no, before that, Fluffy was saying, the question, how do you know the set exists, is a question about the model, not a question about reality. So that's the thing, Fluffy. Like the thing is that when you say this, that is a question about the model, you are already taking a philosophical stand, right? Because you in your philosophical stand, you believe that sets exist, right? And then that you can construct models based on sets, right? If you take that philosophical stand, then that answers the question. You are answering the question on that, but then there are people who may take other philosophical stands, and they maybe then they start actually complaining about your ontological assumption about sets. In what sense sets exist, so you can construct the model for this? I mean, I'm not saying that the answer is wrong. I'm just saying that there is nuance, and that people have been concerned about these issues for a reason. Sets are artifacts of the model, which is set theory. And I think what Fluffy is saying is actually revealing something about your own philosophy, because it sounds that then you are an anti-realist, right? And if you are an anti-realist, then you have probably the way that you, I don't know if you have consciously or thought about this, but probably your philosophical stand is that mathematics is a game of language, a linguistic game. And then under your philosophical stand, your answers are correct, right?
By the way, thank you, Zach.
Okay, apparently Fluffy meant something else. Yeah, so, but yeah, there is a philosophical stand there, and then making it clear. I mean, obviously, I don't want to put words in your mouth or in your chat, but yeah, like making clear your philosophical stand will allow other people to criticize it. Yeah, it's pretty tough to talk about this. No, how are you feeling, Don?
It's definitely like hard to follow. this type of discussion in real time. Like when I'm reading the book, I have the advantage of getting to like reread stuff multiple times in Google stuff. Also, hi Penn Center. Hope you're doing well.
Hi, Ben. I think that Fanbox is gonna settle it.
Oh, it's up to me, is it?
Yeah.
Yeah, you'll be
Yeah.
waiting a while. I've only taken one philosophy course in my life, and surprisingly, it was not a philosophy of math course. That would have been a cool one to take. But
What did you take?
No.
Ethics?
no, I took what was called philosophy of religion,
Oh, yeah, like
which they had at my school.
oh yeah, like I had to take a similar course also. Like basically, the whole course was basically designed to tell you why philosophically religion made sense, right? Like
Oh, is that
instead,
what it was?
like
Huh.
at least the one that I took, it was well, I don't know the name in English, but basically it was giving reasons of why having faith was actually the right thing to do, you know, but
Oh,
through reason, not just because someone told you like, okay, you have to have faith, right? Like this was like try to give you rationalizations of why this is the correct thing to do.
hmm.
Right? It was actually pretty interesting. Like again, like people, yeah, people have thought about these things very deeply as well. Like
Yeah.
why certain religions, yeah, what's good and all that, you know.
You know what I think? Tell me if you agree on this, everyone. I feel like philosophy, the big questions in philosophy are kind of the questions that in some sense seem unanswerable, right? Or at least humanity's been thinking about them for millennia, and we haven't been able to work to solve any of them, right? We're still trying to work them out.
Yeah.
Whereas,
I mean,
questions in mathematics and physics and things, we're actually making progress. We're not spinning our wheels.
but the thing is
Oh,
that like physics used to be philosophy, right? So I mean, at a point in history, it looks like we don't have an answer for those questions. But once like we start making strides and coming up with good ideas to solve them, yeah, we move them out from the realm of physics, right? Like the scientific method. I mean, this is relatively new. Before that, people just philosophized about the stuff and got wrong answers. For example, Aristotle thought that if an object was heavier, it would fall faster.
yeah.
Right now, we know that that's not correct, right? And then there is actually like a quote unquote proof that that Aristotle made in one of his in his books in why like heavier objects fell faster, right? Obviously, the proof was wrong, right?
Yeah.
But it's amazing because it's amazing the influence that these people had because basically we spent like 15 centuries believing that, or like a bunch of time believing that, just because no one dared to question Aristotle, you know. No one questioned no one dared to say maybe this dude is wrong, you know. Until Galileo, right? When Galileo
Yeah.
actually made the experiments and said, okay, it seems like actually being heavier doesn't make you fall faster, you know. It's just yeah. But yeah, like so I think that happens with philosophy. It starts with things that are kind of like unanswerable, but as we gather more knowledge, we kind of make strides and actually improve our knowledge. One of the questions that I think right now is like that is the question of consciousness. That right now we don't really have like a satisfactory answer about what's consciousness and all that. But I think that eventually we will may get more clear answers. But in the past, it might be the question of heat. What was heat, right? Right now, we
Yeah.
have a very good understanding of what heat is. But in the past, it was like kind of like people just philosophized about it.
Good point.
Right. So Don, I remember that you had some list of things that you found interesting. One was the least upper bound thing. What was the other one, or what were the other ones?
There's only one of them that we kind of already like, or I guess I already mentioned once, but I just I guess I feel that if when you ask the question of whether numbers are real, you should talk about which set of numbers.
Yeah.
So in my opinion, the answer might be different.
Yeah, like Like yeah, like obviously, like said, and you could. I think that your point was kind of. I don't remember who was the person who said like the natural numbers are real. No, God gave us the natural numbers, and the rest we invented. Right? There
Oh
is like
yeah, maybe Fermat or
a
something.
quote.
I
No,
don't
no, no,
remember.
no, no, no. It wasn't Fermat. But yeah, so it seems like you were taking that stand that basically the natural numbers are real, well,
Kronecker,
or exist at least.
according to
But
Fluffy.
yeah, but yeah, like yeah, Kronecker. Thank you, Fluffy. Kronecker said that. Um, yeah. So yeah, I'm not sure. I'm not sure what the numbers. I mean, I can tell you which I mean, I think that if you accept the existence of sets, then all the numbers that we use in mathematics are real or exist in a way, you know. But then yeah, like yeah, that brings us to a different question. And I guess everyone can give their own answers, you know. And obviously people through history have given answers. Like at some point, like the concept of number has evolved so much. Like at some point, the rational numbers didn't exist, you know,
Oh yeah,
or people
we didn't
didn't.
have zero for a long time.
We didn't even have zero for a long time. Negative numbers we didn't have, right? Yeah, now complex numbers and all that. I think they are pretty much accepted, um, and they are useful. I think
I was
at the end. Huh?
I was gonna say complex numbers literally get their name from this. Like imaginary numbers, like literally get a name because they were truly imaginary to people. They have no meaning, right? I just realized I was muted. I was trying to say something earlier.
Oh
I was
no.
trying to say I was trying to say Chronoker in my mic, and you didn't hear me. I was
Oh, I
like,
see.
I thought you heard me, and I was like, oh crap. Yeah,
Mm,
all God created the integers, and all else is the work of man. That's the quote I was gonna say
Mm.
out loud. But
nice.
um,
Nice, but yeah, but by the way, like the first person the person who coined the word imaginary numbers was Descartes. It was Descartes, and it was a derogatory term. He
yeah,
also coined the term real numbers because it was kind of like the
Oh.
real numbers versus the imaginary ones. So the real ones were like the good ones, like the ones that weren't just crazy people talking. And and we just accept them eventually because they are useful, right? Like because
Mhm.
we could solve cubic equations using imaginary numbers, and I think that's how it goes, right? We end up accepting ideas once they are useful, or once the generation that didn't accept the idea die, basically,
Mm.
you know.
and useful in explaining phenomenon. So this actually brings up something really interesting to me. One of my favorite quotations is from G.H. Hardy, who said that I've never done anything useful. And in historical context, Grant Sanderson explains that this was in context of war, right? He famously said, I just, in all his number theory, he was just trying to get away from the practical and get away from it. Ironically enough, that's where a lot of the cryptography comes from, right? Is a lot of Hardy's methods. He was trying to be not real about it in the sense that I'm just going to keep this in my mind, keep it theoretical, but it turns out to have practical use. And it actually got accepted because of the utility, right? Whereas maybe Hardy's work was seen as through a pure theoretical lens. And I wonder if there's like parallels that happen throughout history where this imaginary numbers finally get accepted. Zero finally gets accepted. You know, like these things, and even like theories often take a while for things to get to latch on, right?
Yeah, yeah. It takes a while for theories to, yeah. Again, like there is a physicist who said that basically advances just happen when the previous generation dies, and then the ideas
Mm.
of the new
Yeah.
generations get accepted.
Right.
I don't remember who said it though.
No, no, I know the quote though. We were at my Mrs. Pie and I were actually talking about that recently, with in context of lots of different things. So it's just anyway. Yeah, I know the quote. That's awesome.
So if you can find the quote, that'd be great.
I'll see what I can do.
Cool. Ultraproduct says that there is an SMBC comic about that. Yeah, I'm not surprised. SMBC is pretty smart.
Yep. Got to have your
Uh,
Saturday morning breakfast cereal.
yeah. Yeah. Any other thing that you have in mind, Don or Fembox?
Mm,
No, I guess.
Well, the next another cool thing that is cool that I found is this Neurath ship. Do you read that part?
oh,
Do you remember that?
yes. That was in chapter 2 somewhere. Or no. Did I just see it now? There's a ship.
Just one page above, I think. Yeah, around there, a little under that. I think it's actually
Oh,
in
okay.
the
Quinn's metaphor.
yeah, like there. Queen's metaphor, Neurath ship is taken seriously.
Okay, so hey Phobos. So we're talking about a quote. Actually, wait. Make sure I'm getting the right part of it.
It's not the same as the ship of Theseus, I guess.
No,
Similar
it's kind
theme.
of similar. It's kind of similar, but the difference is that, like in the ship of Theseus, you go to the dock and rebuild the thing. So the idea is that basically you have a ship. Like mathematics is like this ship, and you have to build it, but while you are still on the sea, right? Like we reconstruct it, but you cannot like go to the dock and rebuild it. You kind of just keep adding things or rebuilding it as you go along.
Sorry, the as you're saying that, it makes me think of what happened during COVID-19, where people were trying to do things and build a airplane as it's flying, right? Like you're literally doing the thing. That metaphor came up a lot with teachers. Like we're trying to figure this out on the fly. Sorry, you're making me think of this as you're describing the boat thing. Like, wait, this was like an ancient metaphor. Holy crap! Didn't know that.
Yeah,
That's cool.
yeah. And after that, I mean, I can go through my notes. I don't know if you'd like that, and maybe people can interject. What do you think?
Yeah, I was just like rereading the top part to remember like why are we talking about the ship of Nerath in the first place?
Yeah,
Oh yeah. I guess this has to do with the idea of like what role should philosophy have with math, and the author describes it as, you can think of it as philosophy first, as in it should have a prominent role, philosophy last, if at all, of having little to no role, or somewhere in the middle.
yeah, yeah. Yeah, so basically,
Yeah, go on.
he thinks that there is this spectrum, right? Or he proposes this spectrum in which he says, okay, should we do philosophy to guide math? That's philosophy first. Or should we just not care about philosophy at all and do math? And maybe, yeah, either not care or somewhere in the middle. I feel that many mathematicians are happy with the philosophy last, if philosophy at all, part.
Right.
We
If
just
it
kind of
works, that means it's right.
Yeah,
It's the only
exactly.
thing.
Yeah, just basically mathematics is whatever mathematicians do. I think that's fine, you know. But I also think that, like, my impression is that at least all the mathematicians that I think, uh, like, not only famous people, but all the mathematicians, all the people that I think have done good math, that I know, they have like a philosophical stand, and they are kind of aware about. Maybe they are not like specialists in the philosophy of math, but they are kind of aware of what their philosophical stand is with respect to math. You know?
Right. So yeah, I guess if you have any other notes you want to bring up, please do. Otherwise, I'm just going to scroll through and see if there's
Yeah,
another part that
like I mean,
catches my
after
eyes.
that we have in chapter 2 we have the questions, um,
Right.
and the first is necessity and a priori knowledge. Um, so here the question is that, well, first the observation is that mathematics seems to be good at acquiring knowledge, and then that makes mathematics part of epistemology. And then one of the observations is that they distinguish between circumstantial truths and necessary truths. And it seems that circumstantial truths might be something like all American presidents are males, right? Like that has been the case so far, but it's just circumstantial.
Hmm.
But mathematics truths are like things like 1 plus 1 equals 2. This seems to be necessary. Like there is no other way that could be. Obviously, I mean, someone may say, okay, what about Z2 or whatever, but hopefully you see what I'm trying to say, right? And that makes mathematics kind of special because because it's gathering these necessary truths. And then the question is why this is happening. And also the knowledge that mathematics gathers seems to be a priori, meaning that it doesn't require experience. Like you may need experience to understand the problems or to understand the concepts, but after that, you can just follow logic and then you gather new knowledge. Like I don't need to, for example, gather a million apples and then another million apples to say that 1 million plus 1 million is 2 millions. I don't need to actually perform the experiment. Like I trust the math.
Yeah, but you do need to
So
have
that's
eaten
what.
an apple to describe how it tastes.
Yeah, yeah, definitely, exactly. Like this is a different type of knowledge. The knowledge of knowing how things taste. They require experience, so they are a posteriori. Like that's a distinction, a priori and a posteriori. Um, and I mean, many of these distinctions they are interesting, but they require to kind of know much more philosophy in a way, because many of this is based on the works of Kant, and Kant happened to be like so influential for the way that we see the world and for philosophy, that his views are kind of like things that people study a lot. So Kant came up with this distinction between a priori and a posteriori knowledge, and he also came up with the distinction between synthetic and analytic knowledge. And then there is a lot of discussion. He mentions it there, but unfortunately, I'm not that good to explain this well on how like Kant classified mathematics as synthetic a priori, and there is a bunch of discussion about that. But again, that probably is not that interesting to us, I guess. Um, but I don't know if you have any thoughts about that. Obviously, we can talk about it.
Um, well, I guess like building off that, there's an interesting like at kind of contrast the book points out, where scientists like will admit that their fundamental assumptions could be false, but that's not really true with math. Like, you know, outside of some specific examples with like the axiom of choice, you don't really admit that your fundamental things are false. That's
Yeah,
not like
I
a
mean,
serious
I think
consideration.
I think that's an exaggeration. Like the example that he's giving is how science has have these revolutions, right? Like you used to believe something, and then the evidence is so overwhelming that people just accept, like Newtonian physics, right? You believe it, and then the evidence for relativity is so overwhelming that you say, okay, actually the world is like this, right?
Hmm.
And then he says that scientists are more cavalier and they kind of accept when they are proved wrong. I don't think that's necessarily true, but in general, I concede to that. That they are definitely better than mathematicians. But I also don't concede that there are no revolutions in mathematics. I mean, I think there are revolutions in mathematics. They are just maybe more far in between than in science. Like again, like right now we think on terms of sets and all that, but those things were controversial at some point. And now we may have a different revolution moving from
Hmm.
sets to categories. I don't know. Things of that
I
nature. I
guess like
just
you
think that,
could maybe call like what Descartes did with modernizing the notation a revolution.
yeah, yeah, exactly. Things like that, or what a proof was. For example, like people, like the proofs were much less rigorous, right? They were more kind of like hand wavy. Yeah, like the level of rigor that we require now. I mean, this came up through kind of revolutions, I guess. But yeah, like notation stuff. Yeah, or the invention of calculus. It just changes the way, or with Descartes, the fact that you were able to do because geometry used to be done basically in the plane, but Descartes introduced analytical geometry in which you attach equations to figures in the plane, and that's also a revolution, right? The fact that he gives these tools that are so powerful, like to be able to express a line through an equation or a circle through an equation.
Right. Zachary Femux, were one of you going to say something earlier? I thought I heard one of you maybe start.
No, but I'll say this now.
Okay.
Did you guys know that? Or well, I say this like I know this, but I read somewhere that Descartes lived at a time when he would carry a sword when he went out. When he walked the streets, right? That was
He was
the
like
time when
1500s, I
gentlemen
think.
would wear a sword at their waist. Isn't that cool?
Wait, Fembox, wait. So you don't carry a sword when you go out?
Well, sometimes, but not always.
All right, all right, fair.
Oh,
And he used to. I think he also used to sleep in the mornings. So he's a man after my own heart.
Nice. Yeah. Nice. Yeah. So that's one of the things. The next question is the question but this is a question that we have discussed a lot: objects and objectivity, in which we discuss if one of the questions is if objects are real or not, and then if truth is real or not. But I think we actually talk a lot about that already, right?
yeah, I guess I do want to make one more thing about what we said about like revolutions in math, though, because I wouldn't say calculus is a revolution. I would say it's building on the existing foundations. Like a revolution means that something is fundamentally wrong.
Yeah. You're right. Right. But yeah, there are things. I think that the thing with proofs and the level of rigor that we exist that we expect, and for example, the definition of a function. I think that's also kind of like a revolution. Like functions are not the way that we think about them now, or even with the numbers, like the revolution of the complex numbers. This was something that people believed that they were wrong, right?
Yeah.
Do you think that that counts?
I guess so, yeah, because we previously thought we couldn't take the square root of a negative number, and
Yeah.
I guess we're still not sure if we can, but we do it.
We do it, yeah. Yeah, we do it. The next set of problems again is in realism, anti-realism, but we talk about that a lot already. So what about the next one is mathematical and the physical? And the problems that he mentioned is how is mathematics applied in the scientific explanation and descriptions? What is the philosophical explanation for the applicability of mathematics to science? Like, why is mathematics so good at explaining science? Problems of semantics, like for example, what you were saying about the vector field. Is the vector field the described by the equations, or are the equations just a language to describe something else? So that's a question worth worth asking. How mathematics and physics are related. This is a metaphysical question. And the classic one is the uncanny efficiency of mathematics to explain the world. Like, why is it that mathematics is so good at explaining the world? A part that I like is that this Wittgenstein, what they say. So he mentioned Wittgenstein, and he says that Wittgenstein suggests that all explanation must give up at some point. Basically, when you ask for an explanation, you just keep asking until you get satisfied, but it doesn't mean that that's the end, right? You can't keep asking, you know?
Yeah.
Yeah.
Kind of found it, yeah.
Yeah, I like that. Like that, yeah, like at some point you just kind of accept that this is the explanation, but in reality, you could keep going, you know? I like that. It reminds me of kids and how they keep asking, but why? You know? But yeah, like I guess at some point we just are happy with a particular explanation. And yeah, and then the other interesting thing is how things, like, they give the example of knot theory and poles of complex functions. How it's weird that the pole of a complex function ends up being related to some other physical quantities, even though these things, I mean, there is no reason. I mean, when people came up with poles of function, they weren't thinking about sines and cosines and vibrations. They were just doing other things, and then it just happened to be related. Isn't that kind of weird?
Yeah, like there's no intuitive reason why they should be related.
Yeah. Yeah, or how like what Zach was saying, how like Hardy was doing something and then it turns out to be related to cryptography like 60 years later. You know,
Yeah, or like
like
you can solve a PDE that describes how heat moves throughout a rod using complex numbers, and but all the imaginary stuff magically just cancels out by the end of it. It's like,
oh yeah,
why?
yeah, yeah, that's a good one. Um, yeah, I think that's it. And the last part that we read was the last problem was local matters, theorems, theories, and concepts.
Right. This one I
And
was pretty lost on, I think. If this was this one was a weird one.
yeah, so the question is, what kind of theorem of mathematics tells us about the natural world studied by science? Yeah, if I tell you, what would be a good example of a theorem? Like something like, I guess a good non-example would be Banach-Tarski paradox, right? Like you
Mm.
have the theorem that if you got two balls and you cut them and move them around, you got one ball and you cut it and move it around, you get two balls of the same size. That doesn't seem to be saying anything about the real world.
Hmm.
But what about the infinities? Like if we accept the existence that if we were to accept that the universe is infinite, does that mean that we have to accept that the universe contains infinitely many infinites?
Oh yeah, there's a name for that. Uh,
Yeah.
Continuum hypothesis,
Well,
or
the
at least
continuum
a part
hypothesis.
of that.
The continuum hypothesis is the following, which is one of the examples that they give is like you know that there are natural numbers are countable, right? They are infinitely countable, and you know that there are more reals than the natural numbers,
Mm-hmm.
right? So now the question is there any subset of the natural numbers that has more elements than any subset of the reals that has more elements than the natural but less element than the whole reals?
Right.
That's the continuum hypothesis, and the answer is that basically we don't know. But how does that relate to reality? I guess, like to the real world. Yeah, they also mention some logic results with philosophical ramifications. They talk about the continuum hypothesis there, the Gödel incompleteness theorem, and the most interesting might be the Lowenheim-Skolem theorems.
Yes.
I disagree that the answer is we don't know. No, yeah, like the answer in mathematics, we know that these are independent, but the question is like if mathematics is telling truths about the real world, not just the world of mathematics, then what's the answer in the real world? The fact that it's independent is only telling us that, let's say that the real line actually existed somewhere, right? Then we would have to find if we want to model the real line as it exists in the real world, then we would need to find a model that satisfy either the axiom of the continuum hypothesis or not, or some of the negations of the continuum hypothesis. Yeah, like I guess the philosophical question goes with the relationship between the mathematical uh, theorems and reality. Yeah, yeah, yeah. But yeah, the Lowenheim-Skolem theorems, they are pretty interesting. But I don't know if you would like to know more about them, Don.
I've just been trying to speed read to remember what these were even talking about. I haven't found the right part yet, though. So yeah, if you don't
You're
mind.
just right there. You're just right there. You're right. The Lowenheim-Skolem theorems indicate that anything we say about those concepts and objects can be rendered into a theory which has unintended interpretations.
Okay.
Yeah.
And so
I mean, I
they
got
talk about this weird like relativity, where like something you say about the natural numbers might mean different things depending on the context, which
so yeah.
sort of
So
makes
I
sense, but I
mean,
don't quite know what that means.
the way that I think about it is that we are using a language to describe something, to describe could be the world or even mathematics. Let's not get to the real world. Let's think of mathematics. You are using a language to describe the world. And then when you, for example, when you like these theorems tell you that if your language is what we call first order logic, if that's the language that you are using to describe mathematics, um, then you may have in your mind that you are describing the natural numbers, for example. But someone else who listen, who only knows the language and is trying to follow your line of thoughts, in their mind, they may come up with something different than the natural numbers that you have in your mind. That's basically what these theorems are telling you. This is always possible when you use. There are always when you are in first order logic. Well, not always, but there are almost always interpretations that are different than the ones intended.
Can you define first order logic?
Yeah, first order logic. In first order logic, you basically do logic where you have, well, propositions as usual, but when you quantify things, like when you use for all and exist, you can only quantify over objects, but not over collections of objects. That would be second order logic.
Okay, so you can only talk about individual objects, not collections.
For quantification.
Okay.
Like, I can say, for example, for all elements, this happen. But I cannot say things of the nature of for every set, things happen. I can only say
like, collections. Oh, like, okay.
Yeah. Yeah. I mean, it's a little technical, and unless you have studied logic, it's kind of confusing. But yeah, this theorem tells you, because the whole idea of logic is that you have a mathematical object. And then you are trying to describe that mathematical object using language, a formal language. The advantage of using a formal language is that then the concept of proof is very, very rigorous. Like a proof has a very clear definition. And then that allows you to say like what kind of things you can actually prove, right? So yeah, so the Lowenham-Skolem theorem is like the thing that you are referring to is usually called a model. And the Lowenham-Skolem theorem tells you that under certain circumstances, if you have something that you are trying to describe with first order logic, then you have models of basically every infinite cardinality. So you have a model of the natural numbers that has countable number elements, but you also have a model of the natural numbers that have some countable many elements, which is kind of weird. Or even more weird, like the typical Lowenham-Skolem paradox is that you can describe set theory in first order logic. But if you describe set theory in first order logic, then you have a model of set theory that is countable, that basically only have countably many elements. And this is kind of weird because inside that model, there are quote unquote uncountable sets. I know that this is, yeah, it's Skolem paradox ultra product is talking about. But yeah, this is. So if you are trying to explain the naturals, then the naturals are an infinite model. So Lowenham-Skolem applies. I mean, again, if you are using first order logic, Lowenham-Skolem applies. But you could argue that first order logic is not appropriate, and then you could use second order logic, and in that case, you have canonical models for the natural numbers, right? But then that introduces some other problems because second order logic has some other, like in second order logic, you don't have the completeness theorems, right? I don't know. I think that now I'm talking just to myself. So maybe you should have stopped me, Don.
No, that was helpful to hear because I didn't appreciate just the author started using first order everywhere in the section. I don't know what it really meant.
Yeah. By the way, my latest video it kind of touches or starts touching on those ideas. So maybe you would want to watch it.
Yeah.
You know, I know that you watch my videos to fall asleep every night just because you like my soothing voice.
Mm-hmm.
Right. Yeah.
Okay. Yeah. The section in general is just like difficult to grasp, but that was definitely helpful.
Yeah, I think it gets a little bit easier next because the next part is history and then you start talking. The thing is that I feel that the way that he's doing the presentation is that he goes and kind of like teases ideas and then eventually he goes deeper into those ideas like the thing with rationalism versus empiricism. He's going to talk much more in the history, and same with realism and anti-realism. He's going to kind of go deeper. But I'm not sure. Like, did you enjoy the reading? I guess that's the question.
Yeah, it's definitely different. Like I don't know if I read books like this all the time, but I'm glad that I'm like at least learning something about this. It's a real like mental effort to get through it though.
It's also really hard, right? Like that's what I
Yeah.
was gonna say. It's not obvious. Like I honestly had to read every chapter like twice or even three times, because there are so many ideas, you know. So yeah, it's definitely different. Well, I guess when reading math, I also need to read like a few times, like when I'm reading math seriously. But it's definitely not like reading a novel. Well, even some novels you have to read them several times. But I guess it's not like reading a comic strip. Though now that I think about it, I also read comic strips several times.
I'm the same way. I tend to have to read things multiple times. This one was definitely more times than average though.
Yeah.
A lot of this is just like an assault on how we typically do math in the classroom because we just never mention philosophy or like what any of this like means.
Yeah. Yeah. I mean, there are interesting things. The problem, I think the issue again is that for practical purposes, I still think that it's good to be aware of them because often, like classes, mathematical classes, they have a philosophy underneath. And if you are not aware, it doesn't mean that the philosophy is not there. It's just like the philosophy becomes like water, like fish, like that thing with fishes in water, right? Like you know that thing, right? The joke of the two fishes swimming along, and then an older fish comes by and asks them, "How's the water, boys?" And then after the old fish goes away, one of the fish look at the other and says, "What the hell is water?"
Oh, I haven't heard that one, but
Yeah, so it becomes something like that. Like there are many things in which there are underlying philosophies or ideologies, and you just don't realize that they are there until you actually make a conscious effort to think about them. And I think it happens in math, like what we were saying about the language that we use. Why do we say that we construct a line? There is some philosophy underlying that. Um, yeah, yeah. So I think I mean, for me, it's fun. I think at the end of the day, everything I do it if I find it interesting or fun, and to me, it's fun. But I get it if it's not for everyone.
yeah,
It is fun. It's interesting.
Mhm.
It's interesting. I think maybe I first got into philosophy because there was like a cute co-ed at my college who gave me like a book by Plato or something, and I was like, oh yeah, I
Really?
should actually pay attention to this.
Do you still have the book?
You know what? She didn't give me a book. She recommended me a book, and I got it out of the library, so I don't still have it.
All right.
But yeah, it's interesting. But again, I got to say, I think the reason I don't study philosophy the way I study math is because I feel like I don't make any. I feel like I won't make any progress with philosophy. At least in math, I make a little bit of incremental progress now and again, and I feel like I learned. I know more now than I knew, 5 years ago. But yeah, again, philosophy, I feel like that's not within my reach. There aren't any big philosophical questions that I can wrap my head around. But but I agree. If it's interesting, then we all should do what we find interesting.
Yeah. So Don, what are you gonna do for the end of the year, or for where are you living back home?
I'm flying on Sunday.
Right. How long are you gonna be back in Seattle, right? No, in California, right?
I'm currently in Seattle. I'll be flying back to California. I'll be back before. I'll just be there for like a little less than a week.
Oh,
So for everyone in chat, I'm very old. The word co-ed, I don't know if it's still used. I don't know if it's PC anymore, but it used to mean a female student. I think that's what it meant, a female student.
Yeah, so the thing
how
is
I've heard
that this is part of history. Like it used to be the case that females weren't accepted in every school.
Right,
It
right.
used to be the case, and then
It was
co-ed
male
was
only, and then it became co-educational, right? Like the
yeah,
women could get better.
co-educational.
Yeah,
And then
Yeah.
a co-ed they used to say just for female students, right? But
yeah.
yeah, yeah, that's how far we've gone, right? You know, like in just one generation, now we don't have co-eds anymore.
Right.
You know, I never understood what it meant in the movies. Yeah, I got it. I actually got that from the movies because obviously, like, I mean, I didn't go to co-ed or that, you know, like it's just, yeah, but in the movies you hear it. So
Yeah.
Yeah, same.
I'm not even really that old. I mean, by the time I got to college, I certainly never went to any colleges that were gender, restricted or anything. And I
but
don't know that
the
there were any
language
around.
remained, right? Like, but the
Yeah.
language remained, right? Like, I
Yeah.
guess, yeah. Uh,
That's true, Rex. You could say that.
yeah.
Um,
So are you gonna stream while in California, Don?
It'd be cool to sneak one in, but the focus will be family time. I might try and get like a sneaky phone or laptop stream in, but I'm not promising anything yet.
Oh, a cooking stream, right?
I mean, that'd be cool. My mom's kitchen is way nicer than my kitchen, so I have a lot
And
more
we have
room.
actually a way of doing your cooking stream, right?
I mean, I could bring my tripod and my mic, I guess, and that's all
Well,
I
but you know,
really need.
you just have to go and see what ingredients you have at your
Oh,
mom's
true. Yeah.
kitchen, right?
And then just go to Gemini.
Yeah, go to Gemini and ask them.
Yeah, for
Yeah.
those who weren't watching on some stream, we're talking about how you can ask AI like what dishes you can make with the ingredients you have around the house, and so I jokingly said like, "Oh, I only have beer and ketchup in my fridge. What can I make?" And it actually came up with a pretty good idea. So
Yeah, that's kind of interesting. But yeah, I mean, I enjoy this. Again, I know that it's not for everyone. Yeah, I don't know, Don. Will you have me again on one of your streams? What do you plan to continue streaming after this?
yeah, I mean, I'm planning to continue streaming like today, and then if we like another session of this, I think so. I think people seem like they're pretty like into it in chat. So
Yeah. Anyways, yeah, I have to go. Fiona is asking for something, probably food.
Sounds
I thought I heard a cat.
Yeah, she's looking at where I store the treats and like she's trying to reach them, but you can't.
Alright.
I feel so mean when I see her like going through the cabinets and trying to open them to get the treats, you know. But I think if I just let her eat whatever she wanted, I think she will become like a basketball,
Oh yeah.
you know, like pretty soon.
Yeah,
But
my
yeah, so
cats were the same.
Yeah, I've gotta go, but thank you so much, Don. And I feel that I talk a lot today, but
No,
which is
I
not good.
appreciate it because I'm not a very like talkative person, and I'm especially like kind of out of my depth here. So I wouldn't have been able to fill as much like time if it was just me.
Yeah, I
Thanks
usually
for having me too.
But yeah, thanks for being here.
yeah. After talking too much, I usually just go and curl into a corner and regret everything I said as I replayed it over and over in my head. So it's gonna be a fun night.
That's why I'm quiet.
Yeah, that's probably a smart way. All right, thank you, Don. I'll see you around. Have a good one.
Thank you. You
See you
too.
guys later.
See ya.
Bye bye. Thank you, Fanbox. Bye bye.
Okay, so we'll just do a casual like math stream now. This was a fun little segment. I've never done anything like philosophy of math before, so I appreciate people showing interest in it. Big shout out to Slim. His Twitch name is Academy of Useless Ideas. He also has a YouTube channel. I should just have a command to have this like ready to go. So yeah, check him out. He's much more of a philosopher than I am. Song, I kind of just want to play my music right now. Oh, it's too loud. Sorry. I always forget to check that. Got distracted by a jigsaw puzzle. Nice. Okay, just give me 1 minute to update my title. Answering math questions and goofing off. Why not? That's a fantastic stream title. Let me update my YouTube stream title. I hate this YouTube layout change. I don't know where anything is. How do I edit my thing mid? Oh, here it is. Why do websites insist on constantly updating their UI? Math, grad, student, office hours, and studying. Why not? Oh, wait. Okay. So yeah, for everyone who wrote something in chat that I couldn't address, I'm sorry. I feel bad about that, but there's only so much I can do when I'm having a verbal discussion. That's the focus of the stream. I want to like be able to listen to what the others in the call are saying, so that means I can't pay attention to chat as much. The music's a little bit hot. There we go. Okay, what do I want to do right now? Serve co-ed. Oh, really? Yeah, I just think of movies when I hear people using co-ed. I think that's something that we should care about. I don't think co-ed is like the worst word that you could use, but I think we should be on the lookout for words we use that like what do they really mean? Okay. So one of my goals for the break is to let me put this book away. Is to get some semblance of a GitHub for the stream going. And this is probably the first thing that I want to put on that GitHub. I want to this is a code that simulates a vortex. I've shown it many times on stream before. There is this stupid order equals F thing. I want to try getting rid of it, because I don't think it's actually necessary. But for my class, they like the TAs themselves got confused about whether to use it, and so they said to just always use it all the time. But for this, it shouldn't actually be necessary, and I don't want to include something that's not necessary. I'm just going to do comments so it's easier to put this back, though, if it does end up changing my answer. GitHub is hieroglyphics. I'm convinced it's not real. Nobody... I don't really know how it works either. I looked up one video on setting up a GitHub, and so that's as much as I'm willing to look at, I guess. I feel like GitHub is a really good like thing to know. Hey, sudo please. Oh. I spotted a Linux user. Oh, you know, I did make one new visualization for this vortex thing. First, let me show the original visualization that we know and love. This is still my favorite one that I've made. Finding games and like, where's the download button? I know, it's so hard to find the download button. Because it's not like meant exactly for that purpose. I guess. So yeah, so that's still my favorite one that I've made, but I also made a different version of the same one with like a 3D plot, and this one's also kind of cool. But yeah, let's get rid of this order equals F business. Yeah, Danny, I was thinking like it's a tragedy that you and Slim or Academy of Ideas were like have been doing your streaming things at like at different times, because the collaboration with you two I think would have been pretty epic, since you both have a lot to say about like math, philosophy, or like philosophy stuff like that. But I'll just dream about it instead. Let's make the file names different so we can compare. We do. Yeah, so I want to try and figure out if we can get, if it's possible to post a GIF on GitHub, or maybe a GIF. I don't actually know. But the first thing we can have to do is we can just like, once I verify once I check this part of the code, we can check, or we can just like slam it up on GitHub and see what options it gives us. Because I'd also like to do a little write-up with what the equations actually are that it's solving and where they come from, and the method. Eventually it'll get through it. Why are you taking so long? Well, that's the part that I don't know how to actually make. I know that you would need a README. I need to figure out how you actually make those. Also, if we can do LaTeX, that's kind of important. I guess worst case, I could do the LaTeX somewhere else and make it an image. This is pretty much for fun, pseudo please. My background is that I'm an applied math master's student, and this is code that I originally wrote as part of a class. So this used to be a homework assignment that I'm now just kind of like iterating on and improving for fun / to put on a GitHub that would potentially look good on like a job application or something. I really enjoy it. Okay, the code finally ran. I have too many frickin' files in here. Oh, they're going the other way. Wait, no. This is the same way. Okay, good. Original. New. Okay, I think it's the same. Okay, so let's get rid of these commented lines then. Oh, that's all. I clicked on the wrong thing. That's a different visualization that I do want to put up there though too. Yeah, I'm not that good with linear algebra. I do like it though. It's a useful thing to know. Okay, and then let me clean up. Oh, wait. Get rid of the 2s. That was just a testing thing. And then... Ugh, I need to clean out these old visualizations. Delete you. Delete you. Rename you. Rename you. Okay. Where am I going to store these files? Now, I think there's also like a GitHub extension inside of VS Code. I don't know what I'm doing with VS Code, and I kind of almost rather do it manually. Where do I want to store these? I guess I'll make a new folder. GitHub files, because why not? Nope. I've used Git before. I don't really know it though. So I was going to do things the old-fashioned way with downloading files and putting them up on GitHub directly. Let me get these other 2 files. I want you and I want you. Let me bring up my GitHub. Am I signed in? Nice, I am. I guess we're going to create a repository. Yeah, I know what Git is, and I've used it. I don't know. Should repository names be one word? Congenial succotash. I'll use their convention. Vortex simulation. Yeah, we're gonna want the README. I need to bring up the homework assignment. Actually, what might be more helpful for the sake of a write-up is the textbook. Where do we do this? I think it was in chapter 9. Yeah. So this book calls it advection diffusion, but I think that's just like it also counts as Navier-Stokes. That's not the same thing. This is linear, isn't it? Or what is this? I'll put a link to it when like I haven't been announcing in Discord when I like want to like put a link to it. You can probably just find it if you search for Dawn Factorial though. I think Richie Flow is somewhere in there. I don't know. I forget what Richie Flow is. Ugh. Why do I go to Wikipedia for anything? I don't know. It might be. I can't quickly tell though. So we have a dissipation term too. Oh, no, stop. What? Go away. No, what? No, don't highlight. Stop. You're trying to help and you're not. Okay, so in class we actually derived this equation from conservation of momentum in something else. And I was hoping to find an example of someone else doing that online that I could link to. Hmm. Oh, I don't have commands like that set up. I should, but it's kind of difficult with the way that I have my music set up. Um, I'm always willing to let you know what song is playing or what the playlist is though. Creative and unique username. It's been a minute. Hello, hello. Wow, the Navier-Stokes equation was made in the 1800s? Kind of assumed it was more recent. Hmm. What is this? I don't know. I was trying to look through this so I have something to write for the description. Maybe we leave it blank. Just for now. Because I want to... describe this accurately. Duh. Okay, now how do I upload something? Create a new release. That seems reasonable. I'm looking for the file on my computer. 1 minute. Oh, you know what? We should try uploading the visualizations too. Just see if it accepts them. Okay, code and visualizations. Adding the files. Publish. Tag name can't be blank. Where are tags? Oh. What? Well, what should I have for a tag? It's a tag. What? Ugh. Like, am I tagging the release or the actual repository? GitHub is fake? It's true. I much prefer your explanation, Danny. Almost... I still don't really understand what this is. So I'm tagging the commit in some way, but like, why am I required to do this? Like, what type of tags are helpful to have? Okay, okay, V1.0, that's our tag. Good enough for me. V1.0. Sure. Hoo-hoo! I drank it before the stream started. So it's in my stomach, I guess. Oh, you know what? It's been so long since I've been able to show you my tea. Let me go and grab it. I've got... oh, that's the wrong side. Organic ginger turmeric herbal tea. And it's pretty good. I'm down to the last few packets, and I'm glad because it's a lot. There are like 20 something packets in there or something, and I've gotten a little tired of it, and I don't want to buy new tea until I'm through this. But it's still like pretty good. Yep. I'm drinking myself. So my background lights should be on. I really need to get these integrated with the Twitch stream again. Been way too lazy to do that. Yeah, I love ginger. Why does it add these source code zips? I don't know. Now where are the files? Do I need to merge? Oh, what the hell? Wait. What happened to my files? Why are they here and not... What? How does this website work? Why are the files here? This website isn't real. I can see it here. Did I just upload it in the wrong place? Should I just be doing this through VS Code? It might be, Danny. I have a feeling I just need to do this through Git. I thought you could interact with GitHub without ever having Git on your computer. Maybe you can't. Vanilla herbal tea? Ooh, that does sound nice. Okay, you know what? You know what's gonna happen? Oh no. This one? Why are there so many? Oh. Hey, Lucas. Because I am trying to figure out how to put something on GitHub, but it's not working out. Why do there have to be like 6 different extensions? Maybe I'll have to do this off stream. I don't know. I thought this would be simpler. Oh wait. I just realized there's a plus sign here. Oh my god. Okay, wait. I want to delete the old stuff first. Delete. Oh my god. It was here the entire time. Yeah, I've done PDs. I mean, I haven't done my actual PD class yet. That'll be in a few months. But I've started to do PDs. Okay, this is what I meant to do. Right, masters. PDE, it stands for partial differential equation. It's a type of thing in math that you solve. It's usually like a graduate school thing. Okay, so we can edit the README here, I guess. This looks like Markdown. GitHub README. Oh wait, you know what? What happens if you click on one of these GIFs? Can you actually see it here? Oh, you can. Hell yeah. Okay, I'm really happy about that. It's not about the parameters. It's about the number of variables. Well, so basically, an ordinary differential equation only has derivatives in one variable. So, like, all the derivatives are in x or t or something. A partial differential equation has derivatives in multiple variables. So, there might be a derivative in x and a derivative in t in the same equation or something. This is what I wanted. Ooh, that's a fun thing to do, Lucas. Okay. Oh wait, actually, I was thinking of something else. It's pi r squared. 2 pi r is the circumference. Yeah, the area. I don't know if you can how to do that without calculus. There probably is a way. Actually, no. I know how to do the area. I think. I think I could do the area or the circumference just with geometry in sort of calculus, I guess. It does turn out to be that, yeah. I don't know if that interpretation is... It would get you the right answer for why you should be careful. But you're correct. Ooh, so can we embed a GIF then? We should actually just try that now. Exclamation point, alt text URL. So does this work? Hey, that works. Okay, cool. We can actually get the GIF inside of the README. Why are derivatives and integrals only found so late? Derivatives aren't that hard to understand. Integrals are just their opposites. It's because they're. It's not easy to be the first person to think of something, basically. Thinking of calculus and doing it to the like doing as much with it as Newton and Leibniz did is really like impressive. You have to be really smart to pull that off. It's easy for us to understand because we have the benefit of like hundreds of years of simplifying things down and figuring out how to teach this stuff the best way possible. And there is an argument to be made that we have found some of the concepts of calculus earlier. It's just that like they weren't really their importance wasn't recognized in their time. Let me see if I can find it. Why do they say Archimedes discovered calculus? Maybe I hope this will. So I'm not sure that I personally buy the argument, but I want to remember what the argument is. So the typical story is that calculus was invented by Newton and Leibniz independently, but at the same time, I guess in the late 1600s, early 1700s. But then there's Archimedes, who was alive in the BCs, 200 BC, who people say discovered calculus first. But he just, like, people didn't realize why it was important. And so he kind of like scratched the surface of calculus, really. But he did do something really sophisticated that was way ahead of his time. 7th Street Clonk, thank you, thank you. So in a way, Archimedes did something calculus-like, but he didn't quite take that like leap firmly into calculus, which is like actually involving infinity or things actually going to zero. But there's still an argument made that like Newton and Leibniz weren't the first ones to the ideas of calculus. Thought of something. Why not make a math database and make an AI combine a set of 200 items with each other? Function and trigonometry, sine of x and such, then trick. What? I don't really know what you're proposing there, Lucas. Can you use LaTeX in GitHub MD files? Ah, stop scrolling. I don't see the difference between these two examples, but okay. You're handmaking a set of math parts and combine them with each other. I don't really follow, like, what are the like you give functions in trig as examples, but I don't understand what you're doing with, or like what are those parts actually? To solve the two-dimensional advection diffusion equation for the vorticity omega xy and the streamline function psi xy. And then plots the evolution of omega over time. Okay. And I guess that's basically just asking if you can use AI to do the work of mathematicians, which people are trying to do. The issue with using AI for that, I think, is verifying that it's correct. Because it can generate a bunch of data for you, but you're going to have no idea if it's good data or bad data. There's efforts to fix that part where there's sort of like a math proof programming language called Lean, which is like a basically you write your math proof in Lean and it'll check if you made any errors in logic. So theoretically, you could tell an AI to write Lean code for different things and the engine could figure out whether it's right or wrong. Um, but I don't know, the reason to do that or not to do that is the same as the reason you should or shouldn't have AI do anything, really, I think. You will always have good luck in your personal affairs. Okay, that's not a bad fortune. It's simply not the worst one that I've seen. I mean, that's probably going to be the way of the future for a lot of things. Like, AI is going to help mathematicians do math. It'll help artists create art. It's also going to help people make a lot of bad math and a lot of bad art. But that's the direction the world is heading, whether we like it or not. So at least the AI that's out right now, I think that's not a good way to see AI. They are not calculators. They're more like predictors, and their predictions are often wrong. A calculator, if you give it 2 plus 2, it will always tell you 4 every time. If you give an AI 2 plus 2, it'll potentially tell you different things. That's a huge difference. The other issue with AI as it currently stands is that most of it is programmed to just agree with the user, whatever they're saying. And so it's going to mislead a lot of people into thinking that they've done something new or cool or interesting when they haven't. Use a helping tool just like a calc, that's fair. But it's a tool that you have to know what it's capable of and how to use it properly. A lot of people have already become convinced that they've had some good idea because AI told them so, when they haven't really. An eye-opener for me was when someone told me AI doesn't have any concept of the truth. Yeah, exactly. It's just trying to predict what you want it to hear. That's all AI really is right now. I think it's going to get better and better. Like, it's not going to be like that for forever, but for now, yeah. Yeah, so that's fair, Lou. So if you want to use AI when you do math, like, go ahead. I'm not telling you not to do it. I mean, I can't tell you to do anything at all, but I don't just like with AI. I think if you couldn't do the thing you're asking AI to do yourself, then you shouldn't ask AI to do it for you. If you just wanted to speed up something you already know how to do, then sure. But once you ask AI to do something that you don't know how to do, it means you can never verify the output that it's giving you. AI is your teacher? I would be careful about that personally. Oh wait, these are supposed to be partials. D psi dy. Such partial slash omega dx. Okay, we AI is a very bad teacher. I use AI for proofs, which I can check for myself if they hold. Well, Lucas, you were saying... Oh, shoot, I need to take down that pinned comment. We were saying why not make in a math database and use AI to combine different ideas in math. So I'm saying why not, I guess. Fanlock says heart AI. I didn't know that's how you felt about AI. Kind of surprised to see you saying that. I'm not saying it's wrong, but... Okay. All generalized statements about AI are bad. That's fair. Too much rapid evolution. Differences between models and versions. Non-nuanced takes can't capture that. Wait, but is that a generalized statement about AI? Aha! I got you now, Danny. But no, that is a really good point. It's a generalized statement about opinions. Oh, damn. Checkmate. Checkmate, atheists. Yeah, it's definitely like, it's a really rapidly changing field. So, like, anything we say today could very well just not be true tomorrow. Alright, let's see how this looks so far. Oh, well, that looks like shit, doesn't it? Why is it below the image? Radioactive vortex? Yeah. I've already decided what my opinion is. I'm also asserting that I'm up to date on tech developments. Yeah. Listen. Oh no, you're fine, Dan. Like I don't know much about AI personally, so all I really can say are generalized statements. Conditions and the following initial condition. My initial condition, I'm gonna have to translate Python into LaTeX. Slash omega xy0 equals e to the minus x plus 3 squared. I guess we want to frac. Minus slash frac y plus 3 squared over 5 Okay. Copy that. Minus. So I did the first one, the second one, minus x fells, minus 3. Wait. Oh, yeah. Okay, duh. Wait, that's plus, though. Plus. And now we do this one. Minus. Plus. And these are minus, minus. It's probably going to look really bad. But who cares? Okay. This sentence doesn't feel well placed. But I don't know how else to say it yet. So that's what's being solved. That's the initial condition that I'm using. For the method, how do we make a list, actually? Oh, just 1, 2, 3. Wouldn't you know it? Cat. Cat indeed. For whatever reason, they use a cat as an example image. Actually, maybe before we talk about the method, we should talk about how it looks like after you apply the Fourier transform. The two-dimensional Fourier transform in X and Y. Obtain the... Oh, wait. Oh, wait. Oh, I think I just realized I did something wrong in my code. Crap. I did something wrong in my code. Okay. First off, okay, before I fix my code, I committing the changes that I just made. This looks really bad. I'm gonna have to figure out how to format this better. Okay, the thing I forgot is that in class we were taught that when using this technique in Github to solve IVP, we're solving this for it's weird. So when you take the Fourier transform of a real thing, you get an imaginary thing back out. And that's okay, because when you do the inverse Fourier transform, you get rid of the imaginary stuff. But for the technique that we're using here, we're taking the Fourier transform of the equation, solving the differential equation in Fourier space, and then only converting it back at the very end. And this solve IVP thing, apparently, that comes from a library. You apparently shouldn't feed it imaginary stuff when you're expecting. I don't even know what the argument is, but the point is, don't give it complex numbers if that's not what you're trying to do, and that's apparently not what I'm trying to do here. So basically, I'm going to take the I'm going to take myself and split it into an imaginary and real piece, and then concatenate those two things so it all looks real. Omega 0 f vec equals np dot concatenate omega 0 f vec, or I guess np dot real. Np dot imaginary omega 0 f vec. And then now every time we come up, this function up here represents the right hand side. This function is going to get called a bunch of times as solve IVP iterates through the equation. We need to unpack this vector every time. And so, and then repack it at the end. So we want omega f to be omega f vec up to n squared plus 1j times omega f vec n squared onward. That should be good for unpacking. 18, that wasn't it. Um, np.concatenate omega np.real omega t np.image omega t. Okay, and then down in our visualizations, we need to fix this. O equals O, everything up to n squared plus 1j times O n squared onward. That should be good enough. Same down here. Okay, let's run this code, see what blows up. That blew up. Your coffee beans. Oh, wait, hot. I did this backwards. Omega t vec equals omega t dot reshape n squared. And then that's vec. And that's vec. I think that's better? Question mark? I have capital N. I should be using that down here. See if that works. While this runs, I might go use the bathroom quickly. Be right back. Oh, good, it ran. Let's see what it spit out. What it spat out. That looks good. Oops. Sorry for the jiggliness. This one, I feel like I haven't gotten the angle quite right. I don't know if there is a really good angle. Okay, what do you think of the ideas presented in the book related to philosophy of mathematics? A secret message from your teeth? What does that even mean? It definitely asks a lot of interesting questions. It's kind of it gives just like a mile-high view of what the issues are, though. And so as I read more, it'll be good to kind of drill down into the issues a bit more. But it's a nice, like, kind of primer on what type of questions you would ask in, like, math philosophy, I guess. Getting braces in January. Ooh. I hope it goes well and you don't have to wear them for too long. I want to get braces, actually. Once I get a job again. Because when I was a kid, I was supposed to have braces on both my top teeth and my bottom teeth. But for some reason, the orthodontist started with just the top teeth because maybe they needed more work or something, and said that he would do the bottom teeth later. And he gave me the kid me the option of taking a year off from having braces, or just plowing through it and doing and getting keeping the top ones on and getting the bottom ones added on. And I was like, sucker, I'm just gonna take a year off and then never come back because braces are really annoying to have. But now that I'm an adult, I regret it because my teeth aren't really lined up right. So, like, my bottom teeth just don't align with my top teeth, and it's really annoying. So if I want to update existing code, what's the best way of doing that? Edit? Ooh. I guess I can control A. Can I just do it with a file? Edit in place? What if I upload a file with the same name? Will that just write over it? That's what I kind of want. Would I ever like to be interviewed on a podcast, Lex Friedman or Joe Rogan, out of curiosity? That's a good question. It's probably something that would never actually be offered to me, but I think I'm too boring to be on a podcast. Like, the host would really need to, like, carry it. And there's, like, which podcast? I don't even know. Like, I don't necessarily feel like would need to agree with the podcast host. It's like, Lex Friedman, I've heard his name, but I don't really know how he feels about anything. Joe Rogan, I know that I don't agree with him on a lot of things, but that is not necessarily a reason not to go on. Don and Joe Rogan, I can't with this. I would 100% watch. No, I'm not a person who has much to say about anything. I don't think I'd be a very good podcast guest. Ugh. Oh, good. So the same file name thing does work. Jordan, get you elected president. Apparently he can. I don't really want to go into specific issues, but he's overall a pretty conservative dude, it seems. And he's like kind of like the symbol of like, or like a lot of people look to him as an example of like a really masculine dude, and it can go too far. Okay, so I fixed the real and imaginary piece. Like the dulcimer? Is that an instrument? Wow, this is a weird name for a song. It is... I can't even copy paste it. It is Y infinity symbol Y by the artist YY. What is a dulcimer? Ooh. It's like a violin if you pasted it into Microsoft Paint and stretched it out. It's an Appalachian instrument. A member of the zither family, whatever that is. That's cool. Didn't know that that instrument existed. Give you that? Can you play any instruments, Raven? Hammered dulcimer? Is that what you do if you get drunk and then play it? Oh, it's like a table version. Okay. You can try? That's fair. A trapezoidal soundboard. Why trapezoid? You can hammer the dulcimer? I believe you, Raven. I think you could hammer the crap out of that dulcimer. Oh, I guess the trapezoid made more of an aesthetic thing to represent the strings getting shorter. I thought the trapezoid shape itself had some significance, but I don't think it does. That's pretty cool. Oh wait, slash hat. Now things are gonna be wearing hats. Do I plan on becoming a mathematician? It depends on your definition of mathematician, I guess. Because I don't even know what it is. By some definitions I already am, by others I guess not. I plant I'm gonna stammer. I am trying to get a PhD. Like, I'm about to fill out an application to continue on with my current school for a PhD. So if some of the PhD is a mathematician, I don't know who is. So I guess the answer is yes, but yeah, it's kind of a... It kind of depends on how you define mathematician. So if I'm becoming a math teacher, it'd be cool. Like, I think I would enjoy teaching college students. I don't think I'd enjoy teaching high school or lower. But teaching college is like an entirely different ballgame. It's much harder to get a job like that. I mean, I don't even feel that I have to be a mathematician, Fenlux, although I appreciate the kind words. It just depends how you want to define it. A mathematician is someone who can do high level math in my eyes. At the end of the day, a piece of paper is good to draw stuff on. So wait, as you know more and more math, Famous Troll, does it get harder and harder to become a mathematician? So that's kind of funny. You don't have to do math makes okay, yeah. That's fair. I mean, people would debate like what type of math. Oh, sorry, you never said higher level math than you. Never mind. I misinterpreted. Anyone who can do higher level math, yeah, that's fair. There's different cutoffs though. Like the average person doesn't know calculus, but does just knowing calculus make you a mathematician when that's like, if you're studying if you're majoring in math, calculus is like a thing you do in your first year, and then it basically becomes like arithmetic to you by the time you finish your degree. Depending on your emphasis in math. It'd be cool, energy. I don't really have any plans at all. But I think at the right college, that would be a cool gig. There's a lot of places that would not be cool to work, but like a lot of like colleges, but like a community college actually sounds kind of sweet. Get to focus just on teaching. Well, the other thing when you become if you become a professor at like an elite institution, they normally expect you to do research. And not only that, you have to publish a certain amount of papers each year or whatever, or you're gonna lose funding. And so it's a really like cutthroat environment that can get created, where you have to always be doing research, or your like livelihood is under threat. And I would more just enjoy like the teaching bit. I'm not super interested in research. Or it's like I wish to do like some research, but not like I probably wouldn't want my job to be research. Note that we have left, or I guess, note that the nonlinear, does nonlinear need a hyphen? I don't think it does. Computationally, it is better to actually no. This the first equation is now an ordinary differential equation in time that can be solved numerically using normal methods for ordinary differential equations. Now that the nonlinear turn time transforms, these products will become convolutions. Computationally, it is better to take the inverse transforms, compute them in the original solution space, then convert, then transform it back to Fourier space. Does the book related to philosophy of mathematics reference either the philosophy of Karl Popper or the philosophy of Noam Chomsky? Not to my knowledge, but we can always check the index. Let me see what this text is. Oh, this is loading. Oh, that's not important. Okay, you're asking about Noam Chomsky, presumably under C, but check N to be safe. Don't see any Chomsky. Karl Popper. No Carl with a K. Is there Popper with a P? Doesn't look like it. Probably it's better to go look at their Wikipedia pages. Dang, 92 years old. Hmm. Interesting. I don't see much about math in here though. Oh my god, he's even older. What is that, 97? Okay. Believe ideas related to philosophy science might intersect. Yeah, at least for Karl Popper, I wouldn't say it's exactly related. Like the difference between math and science is that math is generally not based. We were actually just talking about this before. Math isn't really based on experience, and this is a pretty like experience-based philosophy, like a priori knowledge. I'm glad Kane agrees. Remade at 86. What a goat. True. The difference between math and science is that math is generally not based. That's true. Math is not based. Feminist, yeah, I'm a full-time student. But it's almost like a different way that math is. Like, it's not philosophically related. It's like an application of math rather than like some intrinsic like linking, I guess. I can tell he can't answer what is math. It's a valid question. I saw you or someone asked that directly earlier, but the conversation was kind of moving too fast and we were focusing on the book. Does probability theory help in mathematics, not intersect with experience-based reasoning? I think you could talk about probability without any like human experience. That's a good question. We always talk about it in terms of human experience with like flipping a coin, and you never know which side it's going to land on. But yeah, probability is philosophically a weird one. Like, probability is really like, it just, we only ever need probability when something is too hard to solve exactly. Like, theoretically, you could figure out what side the quarter will land on every time if you knew exactly how hard you flicked it and like the density of the air or some crap, or like the acceleration due to gravity. Like, if you had all the necessary data, you could theoretically figure out what side the quarter will land on. But it's so difficult that we just use probability to do it much more simply. That's my understanding, at least. Physics only started recently? Probably. I don't know, actually. Ambiguity brings probability. Yeah, this guy's a determinist over here. My kind of people. I mean, I didn't realize that is potent. I didn't realize people take the opposite side of that issue. I guess that's true. I wasn't really thinking about it in those terms. To my understanding, quantum physics intersects with probability theory because quantum physics. That's a good point. Energy. I wish I knew quantum physics, because that is a common example of like probability just being inherently there, as you say. But I don't actually know that for myself. Like, that's you make a good point. I don't know. You can also say that inaccuracy. That's true. They do. People hype on quantum physics to rationalize free will sometimes. That I can see that. Yeah, I wish I actually knew like quantum physics, I guess. You can measure all factors in the smaller scale. If you think quantum probability is reality, then it's problematic. We can't measure. Yeah, so that's like, okay, so yeah, you're saying like the Heisenberg uncertainty principle, basically. You're saying that's why probability comes in, simply because we can't measure everything about a system? Yes, okay. And theoretically, if we could measure everything, then we would know. And so in that respect, it's not inherently probabilistic. I don't know. These are all better questions for Ivan Neo, I think, because he actually knows something about quantum physics and philosophy. If you can measure everything in the system, it's not probabilistic. Okay, I can get behind that, personally. I think energy already knows Ivan, though, so... What do I think of this? Let's see. What do I think of that? That is a physical propensity, disposition, or tendency of a given type of situation to yield an outcome of a certain kind, or to yield a long-run relative frequency of such an outcome. So far, I think it's vague. Or at least I don't understand it. Propensities are not relative frequencies, but purported causes of the observed stable relative frequencies. Propensities are invoked to explain why repeating a certain kind of experiment will generate a certain outcome type at a persistent rate. Stable long-run frequencies are a manifestation of invariant single-case probabilities. Uh, Trouble is inherent to reality, not merely a result of human ignorance of underlying causes. I guess that's what they're saying, yeah. So, Raven, I think the point is that not everyone agrees with that. Potentially. Hmm. Oh, and I see Karl Popper is making an appearance here. Let's read this section. When we repeat an experiment, as the saying goes, we really perform another experiment with more or less similar set of generating conditions. To say that a set of generating conditions G has a propensity P of producing the outcome E, means that those exact conditions repeated indefinitely would produce an outcome sequence in which E occurred, limiting relative frequency P. A deterministic experiment would have propensity 0 or 1 for each outcome. So those generating conditions out of the same outcome on each trial. Non-trivial propensities imply something less than determinism. I don't understand what's physical about this, I guess. I don't know why this probability is physical. It just sounds like normal probability to me so far. Yeah, I really don't know what's up with this. Just me, objective simultaneous does exist, it's just light speed makes it not available. Oh. I don't really know the first thing. I know that's like some quantum thing that people love to think about and say is possible, but as far as we know isn't. I guess at least from this Wikipedia page, I don't... What is physically in the coin that is probabilistic? Or in the environment around the coin, maybe. Causal potentiality is probably... I don't know what causal potentiality is. Quantum mechanic... I mean, I wouldn't know, Kane. I know that quantum mechanics is like, you know, one of the forefronts of physics. And still not that well understood. I have a hard time believing that it's with like I've a hard time believing that the blanket statement quantum mechanics is not rigorous is true though. Like I would definitely believe that there's areas that could and need to be improved, but that seems like a strong statement. Now follow a procedure to solve the ordinary differential equation. So the procedure, solve the second equation to obtain slash hat slash psi. Oh, ah! Oop, the equation, the second equation. Calculate the non-linear terms in the original solution space, then convert back to Fourier space. Use slash hat slash psi. Now follow a procedure to step forward in time the first equation. Transformed non-linear terms to calculate the next slash hat omega t. Based on my understanding, there are two interpretations of probability in relation to whether probability is due to ignorance or not. One interpretation is that probability is due to ignorance of underlying causal factors. The other interpretation that probability is based on the idea that even if the same causal factors are applied in two cases, it's possible for different outcomes to occur in either case. That's fair. It's just that to me, the second interpretation has a hard time explaining. They're claiming there's a physical explanation for probability, and I want to hear what the physical explanation is. That's what I don't understand. Don does GitHub. Mm-hmm. Don tries and fails to do GitHub at least. And Kane, I guess Energy is presenting that there's the opposite point of view that even with 100% precision, there could be probability. At least some people seem to believe that. Yeah, energy. I guess that's where I wish I knew quantum mechanics, because it sounds hard to control for quantum effects. I don't know. So that's my same question, Kane. And this isn't necessarily like what energy thinks. This is just the argument that they want to discuss. But I don't. It's kind of hard to have a debate about quantum mechanics when people don't understand quantum mechanics. At least I know I don't. This is like a neat way where science and philosophy interact, though. That's fair, energy. So Dessen, I'm only applying to my current school to continue on for a PhD. I don't want to go through the PhD application process generally again anytime soon. In part because I just like it's a lot of money with application fees. I don't have enough recommenders anymore. It's been too long since my undergrad days, but hopefully I would have some now. I'm going to University of Washington in Seattle. I guess those are the two reasons. I wouldn't do well with PhD applications right now, but if I have good grades to show on a transcript for a master's and recommenders from that master's, then it would look better. And there's a math department that's not applied. UW in general is a good school, so I imagine their math department is pretty good too. I don't really know much about it though. I'm attending in person. The flag in the background is actually a video game reference. It says New California Republic. It's from the Fallout video games that I really like. And I'm from California. Have I talked to faculty? I mean, I've gone to like office hours and things like that, but not like I don't know any faculty. You thought it was the real? Some people spot it, some people don't. It's kind of funny. There was one person who spotted that it was different from the California flag, but didn't know it was from Fallout. And they thought that I was like an anarchist or something. And that was kind of funny. Chair of my department has told me not to stay for a PhD, so you're taking it as a challenge to get accepted in a way better school. Wait, like that? There's a lot of different ways to interpret that. Was the chair of your department saying you're not good enough to stay for a PhD, or was he saying it's not a good idea to stay for a PhD? Talking about being an anarchist, the ghost father was an enemy. I guess there's nothing inherently wrong with being an. I mean, is there something inherently wrong with being an anarchist? I don't know the position of anarchy well enough to say whether it's something right or wrong. But, I didn't really care. I thought it was funny. Someone to baby in your chat with a PhD, having mathematician. Oh, I mean, I would love for people not to feel that way, energy, because I feel that way around PhDs. I'll say all the time that most people in chat are better qualified to talk about math than I am. You just kind of shouldn't let that stop you from, like, I don't just I think I should just always be trying to learn from others. Everyone has something to teach you, and like both ways. And someone with a PhD has something to teach someone without a PhD, and vice versa. You think that school is not good enough? Maybe both, but she did say it's not a good idea. I think school wants to choose better candidates from overseas. I mean, if you get accepted to a way better school, that sounds like a win-win then. But yeah, so I'm only planning to throw out the one PhD application this year just for the hell of it. I don't expect to get in. I don't know what I'm gonna do after I graduate, but that's a problem for future me. Okay, how does this look? Missing closing brace. That looks great. Missing closing brace. I don't know why I'm making that noise. Oh, did I do an extra one here? Is that the issue? Or what? No, I didn't. Okay, wait. 1 second. Overleaf. We're gonna do some copy pasting here. Actually, wait. Why do I get logged out of this stupid website every single time? Just remember me. Is it this password? It's not that password. Is it this password? It's not that password. Is it this password? Thank you. Okay. Blank project test. Copy all this stuff. Where is the missing? Oh, hot. I think I see it. You asked for PhD 500 times. So I was the plan of calling Penn to get hired. Use the probability. I think... Wait. What do I think? I think... Oh, wait. Now I don't see it. Okay, wait. Here there was an issue. I have 2/fracs. Is that better? This is still formatted really badly. I want to figure out how to center align these equations, if nothing else. Oh, these... Oh, how do you do a wide hat? These hats are too small. LaTeX wide hat. Oh, it's literally just wide hat. Slash wide hat. Slash wide hat. Slash wide hat. See how that looks. Oh God. That looks terrible. Why is this on a different line? Why is that omega on a different line? It should be up here. This isn't looking too shabby though. Well, that's looking shabby. Um... Can we center a line text? Hmm. Do we not? Oh my God. Slash hat. I'm still so confused. Do I have an extra slash somewhere or something? Like, I don't see one. Slash hat slash omega. I wonder if I made a mistake somewhere else in the LaTeX. Hmm. If I can just fix this one line break issue, I think I'll be happy with this page. Something in this. Is it just like a line break thing or something? Well, or like, is it just like the width of the math? I mean, it shouldn't be. What teaching method would I use? I don't really know much about teaching methods for math. Um, I'll definitely try to ground everything I do in some sort of like application, because that's what I like about math. The board, whiteboards for sure. But I don't know much about like teaching techniques or anything, if that's what you're asking about. I'm thinking about signing up for like basically like a journal club that will talk about teaching techniques for the next quarter. I'm not really decided on it though. Experiential versus lecture. Yeah, I don't have a big opinion on that. I think they both have their advantages and disadvantages. I I would probably like, I feel like lectures are like the easier thing to pull off. Like students aren't used to the experiential type of learning normally and are going to be kind of hostile to it, at least at first. Potentially Slim. I'm not really like decided, but I wouldn't mind a job like teaching at a college if the emphasis is teaching and not like research. So it's not. Oh yeah, like a PowerPoint. No, I wouldn't do that. I think my playlist just ran out. Um. I don't know, I'm kind of getting to the end of how much work I want to do right now, because I'm getting hungry and I don't have well, what I told Slim earlier today, that I only have beer and ketchup in my fridge, is actually almost true, because I don't really have much food around the house right now. I need to go pick some up. Um, this Omega hat being on the wrong line is going to be the bane of my existence. I'm going to figure out another time, I guess. Exclusively AI generated PowerPoints with prompts 5 words or less. That would be a fun challenge. Teaching class can be one of the best things in the world. Assisting students can be one of the worst. Yeah, it would feel bad to fail a student. If they were actually trying, at least. What is blame? Is this who you can blame when things go wrong? Kind of actually seems like that, to be honest. Yeah. Okay, I think this is gonna be the end of it for today. Do I? Oh, I do it, and I enjoy many songs. Music is a really big part of my life, I would say. My favorite genres are rap and metal, but there's I listen to more than just those. I'm gonna cut the YouTube stream off here. On Twitch, we'll look for a raid. Anyone's here on YouTube, thanks for being here. Complaining about